We're in.
Shall we play a game?
How about global thermonuclear war?
Hey everybody, it's me, the Shy Hat, and we're doing Hacker Frogs After School today. We're doing Hacker Frogs free hacking, and we're going to be covering a bunch of different topics today. So what are we going to be talking about today? So let's see over here. This is Friday, everybody, TGIF everybody, and we're going to be doing 4 topics as is per usual today over on the stream. And each topic is going to take about 60 minutes or so. So let me put 60 minutes on the clock, and then we can get going. Just a second. Let's put a little more time on there. How about 70 minutes? Okay. So Inebriated says, I was learning from Tyler, then I ended up on your stream, and now I got to watch you a few times and see how it goes. I like different styles and knowledge that people have. Well, I mean, I really appreciate all of the help that. So Samir asks, "Is this your link?" Yeah, that's my link for from my program. It's called the Hacker Frogs. But yeah, I appreciate all sorts of people being here, especially people who are coming from Tyler's community. It sounds like it's a great little community over there. And let's talk about what we're doing today. So the first topic is we're going to be doing human resource machine. So this is a machine that gets you thinking about assembly programming, which is the lowest level type of programming, and it's very closely related to stuff like reverse engineering and binary hacking. The second topic we're doing today is we're going to be doing some coding. So we're going to be solving some labs over at the Temperance CTF website over at hackmyvm.eu, and we're going to be doing some Python programming to solve some of these CTF labs. So the third thing we're going to do is we're going to be learning about some reverse engineering in earnest, and we're going to be using the Nightmare Labs over at GitHub. If you're interested in taking a look at the labs, they can be located over here. I'll just drop the link in the chat. Okay, and let's see. And the last thing we're going to be doing is we're going to be doing some Windows hacking. We haven't done Windows hacking in a while, and I'm pretty sure that this is an Active Directory environment that we're going to be dealing with here. And this is going to be over at TryHackMe.com. It's a pretty popular website. And yeah, that's the last thing we're going to be doing today. So without further ado, let's jump into the first topic. So the first topic is going to be, let's see. It's going to be this one right here, Human Resource Machine. It's an assembly language game. And the next topic we're going to be doing after that is HMV Temperance, which is our Python CTF labs. Okay, so let's go ahead and get started. I think I will hook up the game audio right now. Okay. So we're going to be doing this for the next 60 minutes or so, maybe a little longer than 60 minutes. And then we will move on to our next topic. Samir says, my rank in TryHackMe is this number over here. Ah, okay. How long have you been doing TryHackMe? Slevers, hello, nice to see you here. And what are we going to be doing? Let's do this level over here. It's called the Cumulative Countdown. So if you think that the game audio is too loud, let me know, because the game audio shouldn't be drowning out what I'm saying, but let us know anyways. Samir says 7 months. Oh, okay. And 9 maybe. So do you feel comfortable doing the stuff over at TryHackMe? Have you tried doing their Advent of Cyber event before? That's a pretty good collection of challenges over there. Okay, so cumulative countdown, what are we doing? What is the purpose of this assignment? I think it's something about calculating the volume beneath staircases. Huh. We have to put the intern somewhere? Okay, so did I finish this challenge? For each thing in the inbox, outbox the sum of itself plus all the numbers down to 0. So the sum of itself plus all the numbers down to 0. For example, if the inbox is 3, the outbox should be 6, because if the inbox is 3, then the outbox should be 6, because 3 plus 2 plus 1 equals 6. Okay? Neems, yeah, Samir is on YouTube. So Slevers and Samir are on YouTube, and Neems and Inebriated are on Twitch. So that's why you see the chat like that. Unfortunately, I can't get it set up so that you can interact directly, but you can see what's going on in the chat. Okay, let's continue. So what do we have going on with this program? So init, we grab from the inbox over here, and then we copy to current number, and we copy to count. So these two locations right here. And then we do our loop. So the loop is we're going to bump down the count. We're going to copy from the current number and then add the count. Okay, so I think we add the count, and then if the count is 0, we add the count, we bump down the count. If the count is 0, then we jump to the exit part of the loop, or the exit part of the program, and then we copy from the current number and then outbox. Okay, let's see what happens when we run the program. So we got 4. We put 4 in. We add 7. Okay, we got 9. We bump it down. 10. Okay, it looks like management expected a total of 4 items. Okay, so that doesn't... Let's take a look. So if the inbox is 3, then the outbox should be 6, because 3 plus 2 plus 1 equals 6. So should it be 6, and then subtract 1, and then put the next one? So, okay. Flappy? Is it Flappy? I can't tell, I can't tell anybody's usernames at first glance, but welcome in, Flappy. Have a Hack the Planet. Floppy. Oh, okay. It's an O.
Hack the planet! Hack the planet!
Alright, welcome in. We're just doing a little game right now. We're trying to figure out what exactly they want. Okay, so give me an example. So if the inbox is 4, 1, 0, 3, then the outbox should be 10, 1, 0, 6. Oh, you know what I forgot? I forgot a big loop. So the program immediately ends after the first number, so I need to make a big loop that goes back to the beginning. So this is what I was missing here. Okay, so let's see if the program works now. So it's 4, we add 4, that's 7, and then subtract, and then that's 9, and then the next one should be 10. So this is, so Samir, you're a little confused. So this is a game where we're using assembly programming. Assembly programming is the lowest level of computer programming. So it's lower level than Python, it's lower level than C, and it basically involves a lot of simple instructions, mostly like adding stuff and moving things around from different memory locations. Story time. Hello, nice to see you here. Oh, you know what? I forgot to do something in the program, and yeah, so the thing is that the current number and the count, these need to be reset every time we do this. So after we outbox, we have to copy from 0. And we need to... I mean, maybe we don't need to, because when we inbox, we already copy it to the current number and the count. Hold on. So why is there a 0 here? Samir asked, do you have any PDF or notes? So this is more like pseudocode assembly. I mean, it's more like Scratch assembly, because you're doing a lot of a lot of dragging stuff over, dragging instructions over, and putting them in order. So Samir says, do you have any PDF or notes? Do you mean for this game or in general? Okay, so let's try running it again. So we got 3. So 3, 2, and 1, so it should be 6. So we're just counting down, and we're copying the number. Okay, we got the number, we put in the first number, we get the second number, so it should be just 1. Okay. And then the number 0 should be 0. Uh-oh. I think we've entered a... This is an infinite loop, okay. So we need to make some adjustments to our code over here. So if 0, copy from count, jump if 0. We also need to... We also have to specify something that happens if the what we grab is 0. So if what we grab is 0, then we need to go to a different part. So the different part is going to be so the different part here is if inbox 0. Like this. Okay, so Storytime says, I want to say thanks, I've been enjoying your content. It's really good and it's helped me a lot in CS. When you say CS, do you mean cybersecurity or computer science? Okay, then copy from 0. And then outbox. And then jump over. Okay, so I think it should work. It should work now. Computer science, awesome, awesome. Yeah, I mean, what kind of stuff were you learning in computer science that where I helped out with the content? I'm curious to know. Are you talking about this low-level programming stuff? Okay, so we got 2. So if it's 2, then the output should be 3. Samir asks, where are you from? I am proudly Canadian. We are a Canadian channel. Okay, we got 0. And then we got 6. So this is not super efficient. But you know what? All we're aiming for is to get the job done. 18, okay. And then 21. Okay, and then we're done. Okay, so we use a lot of commands. So this is not optimized at all. So Canada only so many kilometers or so many miles. Well, I mean, yeah, we do use kilometers over here. But it's a weird mix. If we're calculating distance, we usually use kilometers. If we're calculating height and weight, we usually use pounds. Well, we use both pounds and kilograms when we're measuring weight. But for height, it's usually going to be in feet and inches. Okay, so we got another level to do. So level 26, small divide. Division, huh? How do we do division inside of inside of assembly. Okay, so remember last time when I told you you didn't need to divide? Well, now you get to. Great. So for each two things in the inbox, how many times does the second fully fit into the first? Don't worry about negative numbers, divide by 0, or remainders. This might be a good time to practice copying and pasting from a previous assignment. So we're not going to... Floppy says, that's so twisted, like, you really couldn't stick to just imperial or metric. No. It's because we deal with America so much. And Americans... Yeah, so I guess American culture kind of rubbed off onto Canada. Officially, we use metric. But anyways, let's go ahead and make some labels. So here's the init portion, or the initialization portion of the program. Okay, so in the initialization portion, we will grab two things from the inbox. So we'll grab one thing from the inbox, and then, let's see. So I forget what the name of what the names of the items are called when we do division. So is it divisor? Divisor is the name. You know what? I need to look this up because it's gonna bother me if I don't look this up. Okay. So division math terms. So the dividend, divisor, quotient, and remainder. Okay, let's take a look. So the dividend is the number that is being divided. The divisor is the number that divides the dividend. The quotient is the result of the division. So we need a dividend and a divisor section for the code. Floppy says, living there couldn't be worse than Romania, but at least we only use metric. I guess it really does depend on whether or not you're dealing with the United States a lot. Okay, so this is the dividend. Dividend. I get to spell using MS Paint. Great. Dividend and divisor. Okay, so inbox copy to... How many times does the second fully fit into the first? So copy to dividend, and then inbox, and then copy to divisor. Copy to divisor. Okay, so what do we need to do after that? So the divisor needs to... Oh, we also need to count. So we need to count how many times. So here we'll create a count. Okay, and then so dividend, it's going to be dividend minus divisor, and each time it subtracts and it's not a negative number, then we increase the count by 1. So here it's going to be the loop. This is the loop portion. Okay, and then at the end there's going to be the exit. Alright, and after the exit we need to loop back up to the top. So how are we going to do this? Oh, okay, and the count also has to start at 0. So in the initialization process we need to set count to 0. So copy from 0, and then I guess we can label this 0 as well. 0. Okay, so copy from 0 and then copy to the count. And then inside the loop we need to do something. So we need to do copy from dividend and then subtract the divisor. So subtract the divisor. So if it's 0 or if it's negative, we need to jump over to the exit. But otherwise, what we're going to do is we're going to bump up the count. And we also need to figure out how we exit from here. So when we exit, we need to copy from the count, because that's going to be the answer. And then we need to put it in the outbox. Okay? So we bump up the count, and then let's see if this works. So this is going to be the loop. So it's going to be, and then we jump over here up to the beginning of the loop. Okay, let's run the program, see how it goes. So there's not 9, and then how many times did it divide into 4? That's going to be 2. So 9 minus 4 is okay. Oh. Okay. So I figured out something that that is a problem. So the dividend, we need to keep a running track of the dividend in another memory space. So we're going to call this the current number. Samir asks, "Are you a college student?" No, I'm not a college student. I'm in my mid-40s. So that's the current number. So the current number is here. We need to update the current number each time it's subtracted. Otherwise, there are going to be some really bad things that happen. Okay, so let's see. So the divisor, we're also going to make that the current number. So copy to dividend, and then also copy to the current number. And then inside the loop, you're going to copy from the current number instead of the divisor. So copy from the current number, subtract the divisor. If it's 0 or if it's negative, then we're going to exit. Otherwise, we're going to copy 2. Job. I'm a cybersecurity educator, so I do education for cybersecurity as my job, and I do YouTube and I do Twitch, and I do volunteer work as well. Okay, so where are we? So the current number, Ali Ahmed says, what am I looking at exactly? So this is a program to do division. So we're going to be taking two numbers. We're going to be dividing one by the other, but we're not going to be worrying about remainders or anything. And then we're going to be outputting it. So this is it's a assembly language interpretation of division between two numbers. And it really gets you thinking about how complex these assembly language programs really are. Panako Panko has rated the channel with 4 viewers. Thank you very much, Panako Panko. So everybody, did you know that Panako Panko is a streamer? And you can go ahead and watch their channels if you go and follow them over here. So here's a shout out to Panako Panko. Welcome in, Raiders. I'm just doing a little game where we're doing assembly language stuff. So Samir says, what subject do you teach? I teach cybersecurity. So, you know, all sorts of great stuff like, all sorts of technology topics, as well as hard cybersecurity stuff like network hacking and binary hacking and reverse engineering, stuff like that. So today we're going to be doing a lot of low-level stuff. We're going to be doing reverse engineering and low-level programming. Okay, so welcome in, Raiders. Thank you very much. And Panko, I hope you had a good stream. Got the flag. You got the flag. Awesome. You managed to finish it off. Okay, so we need to subtract the divisor, right? This thing over here. And then we need to update the current number. So copy 2. current number, and then we're gonna loop over and over again, and we're gonna keep on subtracting from that until it becomes 0 or negative, and then we're gonna exit, and then we're gonna give that answer to the machine. Okay, so Samir asked, do I teach networking? Yeah, I also teach networking. As much networking as you need to know for cybersecurity. So we got 9, and we're going to be dividing it by 2. So this should be 5. No, this should be 4. So subtract, bump up the count. Uh-oh. Uh-oh. I forgot to do something. So we need to copy to the current number before we bump up the count. Okay. Alright, let's try that again. So 6 divided by 2. So this should be 3. It should be pretty clean. Okay, we got the count. It is 0. So we subtract. So it is not negative, so we bump up the count. Then we subtract again. It is not negative, so we bump up the count. And then we subtract. Uh-oh. We need to bump up the count. Yeah, okay. We need to get rid of this if 0, because if it's 0, we actually keep on going. Okay. Well, you know, we teach on a schedule. We don't teach according to what the viewers demand. So you can see the schedule for what's going on in the live stream on the Reddit. So the Reddit is over here. It's our Hacker Frogs. You can see the stream schedule over there. Okay, so that's 8 divided by 4, divided by 2, so that it should be 4. So let's see if the program works. We got the 0. We subtract 2. It is not negative, so we bump it up. We subtract 2. It is not negative, so we bump it up. Okay. It's not negative, we bump it up again. And alright. So now it is negative, so we need to grab the count and we need to put it in. Okay, so we've got an we've got an ad running on Twitch right now, so I'll also run one on YouTube. And I'll put on an ad on YouTube as well. And let's go ahead and watch some birds. Actually, you know what? We're not going to watch the birds. We're just going to let this program play out. And hopefully by the time the program is over, then the ads will be done. But I do need to take a little water break. Just a second, everybody. Okay, so there's always going to be the 0 example. Uh-oh, something went wrong. Okay. Alright, I need to make a 0 exception. A 0 exception to this. So if the inbox result is 0, we need to do something special. So I guess this is going to be... So if 0... If inbox 0. So if inbox... If inbox 0. Because we can't divide by 0. So if inbox 0, then... So Samir asks, how do you redeem? So we can redeem by doing exclamation point. Well, I mean, there's it's redeem space and then the command. So redeem space SJ, redeem space keyboard cat, etc., etc. So for example, you would do exclamation point redeem and then item, like this. So, for example, we could redeem Hack the Planet.
Hack the planet! Hack the planet!
Okay, so if inbox 0, we need to just outbox it. Well, if the first inbox is 0,
I'm system root.
Floppy says, how do I get these? These as in, what are you talking about these? So if inbox 0, let's see. So the first inbox, if it's 0, then... Actually... So if the inbox is 0, we need to grab... That's an inbox again, and then copy from 0. Copy from 0 and then outbox. We need to put this this stuff over here, just, you know, so I don't get confused. So if inbox 0, then inbox, and then jump again. So jump over to here where you outbox. So, visible, invisible. Hello, nice to see you here. Oh, no. So the hacker bytes, they're not Twitch points, but you just need to spend enough time in the stream, and then you should, you know, get points over time. And visible, invisible says, what's hacking pi? So hacking pi means Python. So we're going to be using Python to write some scripts to do some hacking challenges. Okay, so what are we doing? So that's if the first inbox is 0. If the second inbox is 0, then we have to do something else. So let's see. Wait, where's that coming from? Jump if negative. No, it shouldn't be. Here. Okay, so that's if the first inbox is 0. So we just need to do a check. So inbox, if it's 0, then we need to go all the way down here. So we grab from the other inbox and then we copy from 0. And then we outbox. Wait, we copy from 0 and then we jump up here, which does the outbox. So the other one is... Ayanda asks how long you've been in cybersecurity. So I started learning about cybersecurity 5 years ago. So I've been working in cybersecurity. I previously did a job doing web app security, web app pen testing for about half a year, and that was about 4 years ago. Visible Invisible says, no, I meant to say, what exactly are you hacking with Python? Oh, yeah, we're going to be doing some labs. So let me point out the labs to you. So we're going to be doing these CTF labs. Over here. So these are the Temperance labs from hackmyvm.eu. Okay. So if the first inbox is 0, then that. If the second inbox is 0, then we do another thing. We just grab copy from 0. Actually, if the second inbox is 0, we just need to outbox. That's nice and easy. Okay, anyways, let's run the thing again, see if it works. Alright, so that's going to be 6 divided by 4, so that's just going to be 1. Visible Invisible says, might try them out, but I'm more comfortable with C. I mean, I think C is a really cool language, but, I mean, if you don't want to learn... Actually, Python would be a pretty good language to learn, even if you're more comfortable working with C. If you're learning Python, it's going to be much easier, because you already know C. And there's a lot of C-like things inside of Python as well. Okay, so it's 7 divided by 4. So that's just 1. Let's see. I don't think you can pronounce my name. So is it not Ayanda? 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 Ayende? I don't know. I don't know what it is. I'm just a person who speaks English. Okay, so that gets the job done. So we managed to divide one number by another number. Jason IT Solution. Jason IT Solution, it's like we're gonna practice together from scratch. Well, I mean, this looks a lot like Scratch, yeah. Thank you very much for following. Floppy, thank you very much. Yeah, I have no idea. I have no idea how to pronounce that name, I'm sorry. If you could help me out, maybe I could. It's just that I don't have a guide. Yeah, so we finished that. Let's see if we can do the next level as well. So I mean, the speed is pretty much close to optimal, but the size of the challenge, that's okay. We're not here to be very efficient workers. We just need to get the job done. Samir says, good night. Well, I mean, have a good night, Samir. Let's give you a keyboard cap to play you out. Okay, alright, Visible Invisible, thank you very much for subscribing on YouTube, and it looks like we've got another cutscene to watch. Okay, so everybody, let's take a look.
Hide the planet! Hide the planet! Shut up again!
Okay, so let's get back to the chat. Okay, so Samir is trying to redeem Hack the Planet over and over again. There's a timeout for each one of the redeems, so you can't redeem them too closely together. You might want to try again in about 5 minutes or so. Okay, so Jason says, how good is TryHackMe when you're a beginner? So TryHackMe is a pretty good platform for beginners. I'd say that the most important thing you have to know about TryHackMe is how to search there. So let me point it out. So over at TryHackMe, so the first thing you need to learn how to do is how to search for different modules. So from the TryHackMe dashboard, you go to Learn, and then you click on Learn, and then you click on Search. And especially for people who are on the free subscription, you definitely want to search by the subscription type free. So go ahead and click on subscription type when you're filtering. You select free only, and say you want to look up something like networking. And they've got, you'll see all of the free modules they have for networking over here. Wasabi Cheetah, thank you very much for following on Twitch. Thank you very much. I really appreciate that. But yeah, so the most important thing you need to know when you're using TryHackMe is you need to know how to search on the website, otherwise it's going to be kind of frustrating. But they tell you like which ones are easy versus info, and you're going to look for the easy modules. You're also going to look for the free modules. So you can switch it up over here, and that's how you do it. Okay. So Pwn College is also an option. Yeah, visible invisible is correct. So I don't cover Pwn College on my channel because Pwn College doesn't let people do their stuff on live stream or on YouTube videos. But Pwn College is one of the best. It's one of the best resources for learning about hacking concepts. And let's see what else. Lance Clive says, "What are the possibilities of hacking?" Can you be more specific? I mean, what do you mean by the possibilities of hacking? That's kind of a vague question. If you could be more specific, I might be able to better answer your question. So Visible Invisible says, "I think 7 billion humans is a great programming exercise and should be more commonly adopted." Yeah, I mean, we might do 7 billion humans. It's another one of the games from the same publisher. And we'll do that after we finish up with Human Resource Machine. Okay, so the next challenge is going to be 3 sort over here. So what is this? Ayanda says, "Is it free?" So Pwn College is free, and we're not talking about the games. The games are not free, but Pwn College is free. So if you go to Pwn College, you can sign up for free, and you can learn all sorts of hacking stuff over there. It's a very, very good website. Okay, so we rank all of our employees here. So from the worst performing all the way to the best performing. So where do you rank? Let's give it some thought while we complete this assignment. Okay, so for each 3 things in the inbox, send them into the outbox in order from smallest to largest. Ah, right, love the devs. And get a belt. Are we... Fracker, are you talking about the same stuff? Are you talking about the game, or are you talking about Pwn College, or are we talking about both of them at the same time? Anyways, so we're going to be sorting 3 things today. Yeah, Pwn College. So let's make a thing called... So 0, we'll call this first number. First number, and then we got second number, and then we've got the third number. Okay, and then we got first position, both at the same time. That's kind of confusing. Okay, so we got position 1, position 1, position 2, and then position 3. TIS 100 is... Yeah, I mean, the problem with TIS 100 is that it's not very fun to look at, so it's not a very good stream game. I think the games are good from an education point of view, but they're not very good games for live stream. Okay, so position 1, position 2, position 3, we got the first, second, and third numbers, and I guess we'll copy them to those positions as well. It's definitely a mind challenge. Yeah, I mean, I wouldn't mind doing those games if I could do them on stream, and also if they were entertaining to look at while on stream. Okay, so what do we need to do? So we get those numbers. So this is the initialization. So init. So each one of the programs I do in the game usually follow these same sections. So there's going to be the loop, and then there's going to be the exit. So we're doing a sort of 3 items. So what we need to do is we need to compare the items to each other. Frackery says, "Just need someone cutting soap in a video in a box on the screen while you stream it." Yeah, I don't know if that's going to be what I want to do. Okay, so the exit of the loop is going to be... The exit for the program is going to be pretty easy. It's just going to be grab from... So copy from position 1. and then outbox it, and then we're going to be outboxing position 2 and then position 3. So copy from position 1, copy from position 2, and then copy from position 3. Okay, also Subway Surfer gameplay. Bit asks, says hello Bit, nice to see you here. And what is it? Looks interesting. So this is a game called Human Resource Machine, and it's basically doing programming with assembly. So it's an assembly-like language. So it's a very simple computer. You can do addition, you can save to different memory spots, and you take things from the inbox and you put them in the outbox, and there are different missions that you have to accomplish. Okay, and then, so for all of these programs, you need to do a big loop at the end so that we can go back to the beginning and do the thing all over again. So the loop is going to be, we need to compare position 1 with position 2 to make sure that what is in position 1 is a smaller number. So the smallest number has to be in position 1, the biggest number has to be in position 3, and something in the middle is going to be in position 2. So we need to subtract. So we're already holding position 3, but we want to do position 1 first. So this is going to be P1 minus P2 test. Well, I mean, you know. So P1 minus P2, and then there's going to be P2 minus P3. So P2 minus P3. And then the last thing we do is we do P1 minus P2 again. This is how we check all 3 positions to see if the numbers are in the correct places. So P1 minus P2 again. Okay. All right. So how do we do this? So it's P1 minus P2. So copy from position 1, and then we subtract position 2. Oh, you know what? We need some extra places. We need some extra memory positions as well, because we need to save these just in case we have to change the positions. We're gonna create 2 more of these memory places. So this is gonna be so current number C number 1, current number 1. And then there's going to be current number 2, because this is going to be the temporary storage for the numbers that we're comparing. If we don't have these, then we're going to run into some problems. Okay, so copy from position 1 and then copy to current number 1, and then we copy from position 2, and then we copy to current number 2, and then we're going to subtract. I guess we can copy from we'll copy from position number 1, we'll subtract position 2, and what we're expecting is that it's going to be negative. So if it's negative, then we're going to continue on. But if it's not negative, then we need to switch the positions. So if it's not negative, we're going to enter the next test. And if it's not negative, then we need to do something. If it's not negative, we need to copy from. We need to switch the positions. So copy from the second number, and then copy to. Copy to position number 1. And then we copy from current number 1, and we copy to position 2. So we switch the numbers around. And then we move on to the next portion. And the next portion is going to be, it's going to be exactly the same, except we're copying from different places. So we're going to copy from the second position, and then we're going to copy to current number 1. And then we're going to copy from the third position. We're going to copy to current number 2. And then we're going to do that whole thing again. We're going to copy from position 2 and subtract position 3. So if it's negative, that's what we expect. If it's negative, then we're going to skip to the next test. Otherwise, we're going to switch the numbers. So we copy from current number 1, which is the second number, and then we put it into the third position. Copy to third position, and then copy from current number 2, and we put it in the second position. So copy to second position, and then we need to do the same thing with the first 2 numbers again, just in case there is something weird happening in the middle. Okay, so let's do that again. Can we copy this? Because I'd like to be able to copy from this. I guess we can't. Okay, so the last test is the exact same thing as the first test. So copy from position 1, copy to current number 1, copy from position 2, copy it to position number 2, or current number 2, and then you do the subtraction. So copy from first position, subtract the second position. If it's negative, then that's what we want, and we go to the exit. But if it's not, then we need to switch the positions of the 2 numbers again. So copy from the first number, copy to position 2, and then copy from current number 2, and then copy to position number 1. So this is going to make everything switched up, and then we can exit. Okay, I hope this works, because if it doesn't work, then we're going to have to do some debugging. So we'll run this. We got 9, we've got 6, and we've got 1. So we're going to have to switch around the positions. So 9 and 6 are going to be compared. So this is not going to be negative, so we need to switch around the position. So 9 goes in this place. We grab 9 and we put it in the second position. And then we compare these 2 numbers. Oh, you know what? Hold on. I made a mistake. Ayanda says every topic has a timer. I try to keep time so that I don't spend too much time doing any one topic, because I do 4 topics each time I do a live stream. Okay, so here's the loop. So copy from position 1, copy from position 1 and 2, Okay, here, yeah. This is the problem. So we're going to copy from position 2, and we're going to copy from position 3, and not the numbers. Okay, okay, let's run it again. So we got 9, we got 4, and we've got 1. So we're going to compare 9 versus 4. And we're going to see it's not negative, so we need to switch the positions of those two numbers. Okay. And then we're going to compare the second number and the third number. So we're going to see that this is not negative, so we need to switch the positions of these numbers as well. And then we're going to compare the first number and the second number again. We're going to see that we need to switch the positions of these numbers too. Okay, and then finally, we're going to put the numbers that have been sorted onto the belt and finish this set of numbers. Okay, great. Okay, so we're going to speed this up because we've already done the first set and we found that it worked. Man, it sure does zoom in along. Okay, and that finishes the level. Okay. It's not very efficient. But you know what? I don't care about efficiency. Alright, storage floor. I wonder what's going on here. So we got 15 minutes, well 14 minutes to do this next exercise. Storage floor, what's going on? Big changes are coming, okay. But I see you already know that. You can now access slots on the floor indirectly. Indirectly. Okay. What does that mean? You will see. It's going to change everything. So imagine each thing in the inbox is an address, and each address refers to a tile 0 to 9 on the floor. Your task for each address in the inbox, pick up the letter at that address and outbox it. Congratulations, you can now access tiles on the floor indirectly. Observe this example to see how it works compared to what you've been doing so far. So copy 12 and copy from 12. Copy, so 12 is, so the number 12 spot here has the number 8. So let's just play this out. Copy 12. So copy 12. Oh, I see what's going on. Okay. Just a second, everybody. We got ads running on Twitch, so we'll run we will run one on YouTube, and we'll also put on the birds. Okay, so everybody hear the birds. We'll be back in about 20 seconds. Just need to have a little water break. Okay, let's get back to the game. Okay, so I think I see what the difference is. So Floppy says, if I'm on Twitch, should I see the ad and not the bird? I mean, it really depends if you have your ad blocker. If you have an ad blocker, you're not going to see any ads. If you don't have an ad blocker, then you should see the ad and not the bird. Well, I mean, you'll see the bird, because I'm pretty sure that the ads stop. What they tell me when the ads are running is a bit ahead of the schedule. So you'll see the birds as well. You'll see the birds and you'll see the ad. Okay, so grabbing 12 means that I grab the number 8 over here. But if I grab the indirect reference to 12, So 12 contains an 8, so I'll grab whatever's in 8 instead. So, Floppy says, should I disable the ad blocker? I mean, do what you need to do. If you don't want to watch ads, I mean, it's fine. It's fine. Cypher says, I think McAfee is hacking. I've checked everything that could be doing it, and it could only be McAfee. So, I mean, you could disable McAfee and see what happens on your computer after you disable it. And if you see that the performance is better, then maybe you should consider replacing McAfee with something else. Okay, so what do we need to do here? So your task: for each address in the inbox, pick up the letter at that address and outbox it. Okay, so pick up the letter at that address and outbox it. So I guess this is the initialization, the beginning of the program. Cypher says, something resets my computer out of nowhere, and after the reset, the search engine is changed. I mean, that certainly sounds like a big problem. I would try disabling McAfee and then see what happens. So disable McAfee, restart your computer. See if it's different, and see if the resets happen on the computer. So the other thing you could do is you could download another antivirus and scan your system using that other antivirus. I suggest AVG. I've had a pretty good experience using AVG. Try using that, and let us know what happens with your computer, Cypher. Thank you. Thank you very much. Okay, so what are we doing? So I think what we need to do is we need to inbox and then copy to we'll copy to this one over here. So we'll just call this one the current data. But it certainly does sound like there's some sort of virus on your computer, Cypher. And yeah, I mean, if your Windows Defender is off, definitely turn your Windows Defender on. It's a pretty good Windows Defender it's pretty good at preventing malware from running most of the time. Okay, copy the current data and then copy from the reference of current data and then outbox that. And I guess this is the loop. The loop is just this. I mean, this seems pretty simple, so I don't think we need to do anything more complicated than this. So this is going to be the loop. Okay, let's run it. So we grab 2, we grab 1, well, whatever's in here, and then we grab that letter. We grab that letter again, and then we get this. We get this letter. Okay, and we grab the number 9. We grab this, and then we grab the last letter. So this is pretty similar to a concept in assembly language called loading the effective address. Okay, so I guess this was the intended answer, great. Okay, and I actually wonder whether or not we're going to have enough time to do this one. But Cypher says Windows Defender isn't picking it up. So are you in RSA? Am I in RSA? What do you mean by RSA Ayanda? So Cypher, yeah, I'd consider downloading another antivirus program and giving that a shot. If for some reason you can't find the you might also want to run the antivirus in safe mode in Windows. You want to look that up. Let me go ahead and give you an article that you can take a look at. So AVG antivirus scan safe mode. Okay, so running a boot time scan in AVG antivirus from Windows. So let me get the link. Okay, so give this a try. Okay, so 30 string storage floor, great. Special covert assignment. Okay, management is requesting strings from the floor. Let's just process the strings, and not read or discuss what they say. It would be impolite to read messages intended for somebody else. And forbidden. So for each thing in the inbox is an address of a tile on the floor. For each address provided in the inbox, outbox the requested item from the floor and all the following items on the floor until you reach a 0. Repeat. Oh. Get... Okay, so I think we inbox, and then this over here, we're going to call this the current data. Okay. RSA, South Africa. No, I'm Canadian. I live in Canada. Mohammed, nice to see you here. Welcome to the stream. Okay, so we're gonna copy to the current data, and then we're going to copy from the current data and then put it in the outbox. So I guess the initialization is here, so init. And then the loop is going to be here. Let's see. So the loop is loop LOOP. Thank you very much for redeeming the Budweiser Frogs, GX000. How was everything last night, GX000? Did you get out at a reasonable time? There were a lot of people drinking a lot of booze at the cybersecurity event last night. Okay, so the exit is going to be, well, if 0, then we're going to loop back up. A little tipsy, no after party, was out of there by 10:45. 10:45 is really, really late. For me, I was out of there by like 8:30. Okay, so the exit is just going to be a big jump back up to the top. And what are we doing? So copy from the data, and then outbox it. And I guess... So copy from the data here. What do they want us to do? Until you reach a 0. So we don't actually outbox the 0, it looks like. So we need to bump up this thing. And if it's a 0, then we go back over here. Otherwise, we're just going to keep on looping around. Is this going to be? Is this what we want to do? I don't know. Okay, so let's Matthew Welty. Hello, nice to see you here. Let's see if this works. So grab this, put it here, and then yeah, you can't bump with the letter. What would that even mean? Oh, you can't bump with the letter? Okay, so we don't bump the letter. We bump the data number. Okay. So we bump this thing. Okay, let's do that again. Okay, we put it here. We grab the T. We put it in here, then we bump up this number. Then we grab this. We put it here. Ah, okay. Yeah, okay. Let's step back. So we actually grab the 0. We're not supposed to grab the 0. So copy from the data. If the data is 0, then we need to exit. I'll put like 5 more minutes on this topic, because I think we can get this done within the next 5 minutes or so. Okay, let's run it again. So grab the 4, put the 4 here, then grab the T, put it there, bump up the number, grab the H, put it there. The next number is 0. If it's 0, then we just grab the next thing, and then we repeat the cycle. Okay, so what is the message that's being output here? So the target X the target is wake. Oh. Awake. T. Take. Take this. Memes asks, what is the significance of the game? So the game shows us a lot of low-level programming concepts. So by low-level programming concepts, we're basically talking about assembly language, and understanding assembly language helps you a lot when you're doing reverse engineering and binary hacking. So stuff like buffer overflows, and so heap buffer overflows, stack buffer overflows, return-oriented programming, and all that other low-level hacking stuff. So okay, we can go back to the elevator. We did the challenge, great. And we're going to move on to the next part of the stream now. So we're going to be doing some Python programming next. So let me get that ready. So topic 2, no. Topic 2 here, and topic 3 here. Okay, so we're going to be doing Python programming for the next hour or so, and then after that we're going to be doing our reverse engineering intro. So we're going to put 60 minutes on the clock, and we're going to stop the game, and we're going to play some other music. Okay, so let's put on some good old Space Jams. All right. So what we're going to do is we're going to be solving some of the challenges from this game over here. So the game is called Hack My VM Chapter 3 Temperance. So these are CTF labs. What's your PC configuration as floppy? So I think I've got my specs over here. So I put them in chat. Okay, and let's see if we can do these labs. So we're going to be doing level 26 because that's where we left off. We've done 20 up to, well, this is level number 26, so we've done 25 other levels before this. You'll need to have an account over at hackmyvm.eu if you want to follow along with us. And before we start, I need to set up a little environment to do coding. Bros asked how much RAM does he want? He said all the RAM. Well, I mean, I run a lot of virtual machines. This machine that I'm using right now is a Kali Linux machine on top of a Windows machine. So that already eats up a lot of RAM. So I got a lot of RAM because I run a lot of virtual machines. Okay, so this is Temperance. The last level we solved was this. And if you want to take a look at the at all of the solutions or the code, the scripts that we wrote, you're going to find them over here. So what we're going to do is we're going to take our script from level number 25 and we're going to be modifying it to solve level number 26. Okay, this is the part of the window, but this is the window where we're going to be doing our coding, and this is the window where we're going to actually run Python. So you're basically running a VM in a VM. I'm not running a VM in a VM. I'm just running a VM. I'm running Windows, and Windows is my host OS. The VM is in Windows. Cypher asks, is it bad to keep multiple virtual machines, or should I just keep one at a time? If you don't need to run more than one virtual machine at the same time, definitely shut off the ones that you're not using. But sometimes you do need the virtual machines to be running at the same time. So in the case that one virtual machine is attacking or is interacting with another virtual machine. Okay, so we're just going to create a script called level 26 because that's the level that we're doing. Paste in the code, save this out, paste in the code, save this out, and then over here, this is where we run our code. Ayanda says, have you tried Code Crafters before? I've never heard of Code Crafters before. Frackery says, looks at Cubes OS. I think I've heard the name Cubes OS before, but I've never really used it. Okay, so what are we doing over here? I need to do an intro for YouTube because I turn these into YouTube videos eventually. Just a second, everybody. Okay, everybody, this is a guided walkthrough for level number 26 from the Temperance Labs over at hackmyvm.eu. So for each one of these levels, you need to take a look at what the level wants you to accomplish, and then we can start the level. So the mission says, in this mission you will receive a PNG encoded in base64. You must decode it and send the number found in the image. So send the number found in the image. Alright, so for example, we got this number right here. So we're just going to copy this. So this is a base64 encoded PNG. And we're just going to go over here. We're going to convert it back into its original form, like this. So base64 decode it. So this isn't solving the level, it's just we want to see what's going on over here. So base64 decode it, and what we're going to do is... Whoops. Why did I use the wrong symbols? Anyways, we're going to put it into an image called test.png. And then after we do that, the PNG has been converted back into its original form. We run file on test.png. It is a PNG image data. what we can do is we can actually view the image by using xdg open on the file name. So test.png, and we see there's a number in here. So what we need to do is we need to somehow use Python to read the number in the PNG, and then we need to send that number back to the server. Frackery says, in Cubes OS, everything is in a VM. That sounds kind of excessive. Brian's, hello, nice to see you here. Zooted says, what's your streaming schedule? I feel like I always miss them. A Monkey Man says, hey, hi. Okay, so the schedule is always, it's going to be on the Reddit over here, so on our Hacker Frogs. Cubes OS is super safe. Well, I mean, it sounds kind of safe because it's got everything segmented away. So how are we going to get Python to read this number inside of the PNG? So we're going to be doing some research, and we're going to try to get this done. Let's get out of here. Okay, so what we're going to do for this level, this is kind of bothering me. So what we're going to do in this level is we're going to modify the code from the last level, and we're going to solve the next level with the modified code. So I don't think we need the request module for this level. So we're going to use the socket module to do most of our work. So the socket module is Python's way of interacting with arbitrary ports on remote servers. So for the socket module to work, we need to have a host and a port number. In this case, it's going to be temperance.hackmyvm.eu as the host, and the port number is 9988. Let's see. Floppy says, the one guy who runs a Kali VM using QMove from Arch WSL. It sounds kind of complicated. GX000, is that you, Kyle? Kyle, is there a Kyle in the chat? If there's a Kyle, put your hand up, because GX00 is calling out for you. Okay, so what we need to do is we need to create a socket object with the socket module to interact with the arbitrary port. So this is how we do it. So socket.socket, socket AF inet, socket.sockstream as S. So the socket object that we create is called S. So to interact with the server, we just need to do socket.something. So socket.connect, socket.receive, socket.send, stuff like this. So this lets us communicate over those arbitrary ports. So the first thing we need to do is we need to communicate and send level 26, because that's the level that we're trying to solve here. Kyle was talking about how he runs Cubes OS last night. Coincidence? I think not. I don't... There might be more than one person who does that. Okay, so we're going to communicate with level number 26, and then we're going to receive the challenge over here. So to receive the challenge, we're going to do we're going to use the socket object socket.receive. We're going to do socket.send, and we're going to receive the initial data from their server over here. Each time we're receiving data from the server, we're going to receive a kilobyte, which is 1024. So what we're going to do is at each point in the script writing over here, we're going to make sure that this small section of the code works before we move on to the next section. Okay, so we're going to write out this code, and then we're going to run the code in the other window over here. So Python level 26.py. Okay, so we received the base64 encoded PNG here, and what we need to do is we need to turn this back into its original form. So I'm pretty sure I know how to do this, but let me just do a little search just to make sure. So let's see, base64 encoded PNG, convert back to original. I mean, I'm pretty sure I did this in a previous level. Okay, so base64 decode this thing. Oh, okay. So base64.b64 decode. Okay, and so we're going to need the base64 the base64 module to work with this thing. So the next thing we need to do is we need to convert the bytes from base64 to its original form. Okay, and how do we do that? We're going to call this original PNG. So original PNG is going to be base64 decode on the data2 object over here, and then we'll print something out, something like this is the data from the original PNG file, and we're going to print out original PNG. Okay, and let's see if this works. Okay, let's run the script. Base64 has no attribute base64 decode. Did you mean base64? Wait, what was that? Base64 B64 decode. Oh, okay. It's B64 decode. Okay, well, let's try that again. Okay, so it looks like it worked. We got the original PNG back. This is the data from the original PNG file. So these are all bytes. So I think it doesn't really matter that they're bytes right now, but what we need to do is we need to... Okay, we've got an ad running on Twitch, so we'll run one on YouTube. And we'll put on the birds. How about we put on this bird? Okay, enjoy the birds having their little bath, and we'll be back in 60 seconds.
What are you?
I'm system root.
Okay, let's put the birds away. Bro's the ultimate chiller. I mean, he's these birds love taking their little baths. All right, so yeah, Jason, you said that you don't see the lab. I mean, I can give you a link to the lab if you want to join in with us. You're gonna need to have an account and be logged in to hackmyvm.eu in order to see this stuff. Okay, so now that we have the PNG in its original form, we need to read the thing with OCR technology. So OCR is, what does it stand for again? Okay, so OCR image to text. It stands for optical character recognition, I think. And OCR is basically reading text in an image and then returning the text. So we're going to try to find out Python OCR module. Maybe we can just ask the, indirectly ask the AI, how do we do OCR with Python? Okay, so optical character recognition with Python is commonly achieved through using libraries that leverage pre-trained OCR engines. Two popular choices are PyTesseract and EasyOCR. I mean, I think I've heard of PyTesseract before. Okay. So we need to use both PyTesseract and we need to use PIL. So PIL is the Python image library. And this is a library that's used to interact with images, or picture files rather. So PyTesseract, I'm pretty sure we have it installed. We can check. So we can check if we've got PyTesseract. So Python, we just run Python by itself and we try to import PyTesseract. Is that how you spell it? Okay, so PyTesseract. So there's no module named PyTesseract, so we need to install this. That's going to be a big pain in the butt. PyTesseract. All right. So this is what we're going to do. We need to install this thing. Okay, we'll exit out of here, and we'll create a, what is it called? A Python virtual environment. This is something that you have to do every once in a while because I hate managing Python modules with a passion. So Python mvenv, so virtual environment. We'll just call it my environment. And then we'll do virtual environment, my environment. Did I? Oh, okay, I misspelled that. Virtual environment. Or just use the break system packages to installs over the entire system instead of just in the current environment. So I mean, I use virtualized environments so that I don't have to worry about stuff breaking. And then we move into the my environment directory. And we activate it by doing source bin activate. And now we're in our own environment. So we just need to install the proper library. So it's pip install, what was it, PyTesseract? And that's going to let me install the PyTesseract thing. I'm not breaking anything else, hopefully. Just move back into my virtual environment here, and we can keep on going. Okay, so, I mean, it really doesn't matter for editing the file, but for running the file, we need to run it inside the virtualized environment. Okay, so, let's see. Import base64, import PyTesseract, and import PIL. And what were we supposed to do? Import PIL, import from PIL, import image. So PIL is a standard library. We don't need to worry about that not being available. Is that image with a lowercase or uppercase? That's an uppercase I. Okay. So we just converted the bytes back into its original form. The next thing we're going to do is what? So load the image. Image equals image.open. I mean, we don't need to load the image. We just need to specify the image. So image equals image.open. So what if we want to... I guess we can just specify this as the image and then do the OCR. So OCR is going to be text PyTesseract image to string image, and then print the thing. I'm not sure if we need to do this part or not. I'll try not doing this part and see if it actually works. So we're going to get the extracted text. Get the extracted text, and we're going to call this extracted text. It's going to be, let's get rid of some of this stuff and comment it out as well. So what's this thing called? So PyTesseract image to string on image. Okay, copy that. Okay, and it's not image, in this case it's going to be original PNG. Okay, and we'll try printing it out. So this is the extracted text. And we will print it out, extracted text. Okay, write that out. Let's see if we can actually run this, or if it gives us a big error. Unsupported image object. Okay. Daz says hi. Hi, Daz. Nice to see you here. We're just doing some Python programming. So, Okay, so let's see, using unsupported image. So I mean, this should be a PNG. Okay, so what do we search? So Python base64 encoded PNG PyTesseract extract text. Okay, to extract text from a base64 encoded PNG using Python and PyTesseract, decode the thing. Load the image data from PIL or pillow. So PIL. So what part of the code is going to do that? So extract text. So image data equals. So this over here. So the base64 decode this thing. Image data. We need to transform that further. So image.open IO bytes on the image data. Okay, so this is the part that we're missing. Okay, so Floppy says, now image making the script in some like C, like that one guy said. Well, I mean, I'm not really that good with C. I can do some very basic stuff with C, nothing super complicated. Password wrong. Password wrong. I mean, wait, where are we dealing with the password? The portal has a glitch. I'm not too sure what you're referring to, Jason IT Solution. On the labs. Oh, the portal has a glitch. Well, I mean, I was able to log in. I'm not too sure where the issue is. Okay, so we need to do something like this. We need to open the thing as an image. All right, so let's go back. So I guess before we extract the text, we need to do something else. So open the image with the PIL module. Okay, so this is going to be image.open IO bytes IO on the original PNG. Okay, and I guess we'll call this the PIL image. And there's nothing really to print associated with this. From here, we can try to get the extracted text. And to get the extracted text, we just need to make sure that we're running on the right stuff. So the right stuff in this case is going to be PIL image. Okay, and let's see if this works. So name IO is not defined. Did you mean ID, or did you forget to import IO? Oh, does that, okay. We might have forgotten to import another module. So import IO. Okay, let's see if that solves the issue. So Tesseract is not installed, or it is not in your path. Tesseract is not installed. Are you I mean, it's installed in the virtual environment. Hold on. Let's check. Import PyTesseract. Yeah? I mean, we managed to... Are we using PyTesseract in the other code? So PyTesseract dot image to string return text. I'm not too sure what's going wrong here, but we'll give it a closer look. So import IO, we've got all this stuff that we imported. We're currently looking at this. So extracted text equals pytesseract.image-to-string PIL image. So PIL image is image.open IO bytes IO original PNG. Let's try that one more time. We'll take a look at the error messages a little more carefully. Okay. So everything works up until this point. So up until this part of the code, it all starts to go south after the PIL image definition over here. Namame says, do you know how to code or how to bypass an activation bypass for iPhone 15? This is a place where beginner cybersecurity students come to be introduced to cybersecurity. We don't do iPhone hacks, unfortunately. You probably want to look in some other places if you're can you hack my ex's Instagram type question? Kind of. But Namamez, I don't think we can help you there. Okay, so let me get the error over here, and we'll feed it to the AI. Maybe it can help us out. So it says Tesseract not found error. Tesseract is not installed, or it's not in your path. Can I not run Tesseract? No such file or directory Tesseract. Okay, so I mean locate. Is Tesseract in here? No, I don't think it would be in here. Let me try running it from inside this directory, just in case. So first of all, let me write out this thing. We'll copy it over to the virtual environment directory. So move level 26 to my env. Okay, and then we'll move in there. We'll edit from there. This is why everything. This is why I don't like Python. Everything is fine, but the constant errors with libraries and updates takes up the most of the time. I mean, it can. This is why we like to use standard libraries instead of custom libraries. Okay, let's try running it from here. Still got those errors. Let's try asking the AI. Maybe it can help us out. Or we could legitimately install PyTesseract. We could give that a try. Okay, let's exit the virtual environment. Whoops, that just exited everything. Okay, so pip install PyTesseract. Okay, so this is an externally managed environment. If you wish to install a non-Kali package Python package, create a virtual. Oh, so they want you to use virtualized environments to do this stuff. Okay, that's fine. Let's do this again. Okay, and then RogueX, hello, nice to see you here. Welcome to the stream. Okay, so source bin activate, and then pip install PyTesseract. So PyTesseract is already here. So I mean, I should be able to run this stuff now. We've got the level script in here. So we're just going to run this, and it gives us an error. I haven't used Python in a year. Okay, so I'll try giving the error to the friendly AI, and maybe it can help us out. Okay, so here, what do we got? I am running Python in a virtualized environment. Environment. I have installed PyTesseract, but I still get this error message. Okay, the issue is that you've installed the Python wrapper, PyTesseract, but not the actual Tesseract OCR engine that it depends on. The PyTesseract package is just a Python interface that calls the system Tesseract command. So we need to install the Tesseract OCR engine. Okay, so it seems like I need to install more. So sudo apt update install Tesseract OCR. I need to, this is an actual package. Okay, let me, okay, let's do this then. Let's do this outside of the virtualized environment first. So sudo apt install, what is it called? Tesseract-OCR. Okay. Sliver says, I mean, that was the last time I made a brute force tool, and it barely worked. It needed actual prayers, but we did test it in the class, and it worked somehow. Okay, so we need 24 megabytes. I will sacrifice those 24 megabytes. Okay, so Tesseract OCR. All right, let's see if it works now. Let's go back. Oh, we were doing this in another window. Which window were we doing it in? Is it this one? Here it is, okay. All right, let's try running it now. Okay, it worked. Oh, man. All right, so we got the extracted text, and all we need to do now is we need to send the extracted text back to the server, and that's all. So the extracted text, I wonder if the extracted text is a string. It should be a string, but just in case, I'm going to check. So we're just going to check over here. So we're going to just print extracted text, and we're going to put type around that. So type, we're going to see if it's a string or if it's an integer or whatever. Imagine you mistype something and download the tool that the virus is. That's a sudo apt install virus. Is that it? Type extract. Oh, we needed. Okay, I misspelled. So if you don't spell properly, you don't get to hack everybody. Remember that. Okay, so this is a string. So it's a string. All we need to do is we need to convert this back into bytes, and then we can send it back to the server. So this is what we're going to do. So I'm pretty sure this part is pretty standard for these challenges. So convert the string into bytes. In this case, it's going to be extracted text. Extracted text dot encode into from UTF-8 into bytes. So this is the string converted to bytes, and just for fun, we'll test this part of the script to make sure it works. Okay, so this is the string converted to bytes. These are bytes, awesome. And then we just need to send it back. So this is the part where we send it back. So send the challenge, s.send the bytes, and then we receive the flag, hopefully. Let's run this, and if it's successful, then we'll have finished the challenge. Okay, so it worked. So let's talk about what we did, or what steps we did to finish this. So the first thing we did is we communicated with the server. They sent over a bunch of bytes, which was a base64 encoded string. So what we did is we converted the bytes back into its original form with this part over here. So original PNG is base64 decode on that data. Slever says, found a new way of having fun when I'm bored. Slevers, I hope you're not planning on flirting with me. Anyways, but I'm glad you have a hobby. That's great. So what are we doing over here? Okay, so we convert the data back into its original form, which is a bunch of bytes, and then we use the OCR library, so the PyTesseract optical character recognition program, to extract the text from the PNG file. And we get this text here, we convert this back into bytes, and then we send that off, and then we get the flag for the challenge. So HMV CAPTCHA numbers. Okay, so let's copy that, and let's send it back. Well, let's submit this flag and complete the challenge. Okay, they're going to make me... Oh, I've submitted the flag successfully. Great. All right, everybody. That was a guided walkthrough for level number 26 from the Temperance CTF Labs from hackmyvm.eu. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, Hacker Frogs out. Okay, so let's go ahead and go back to... And we're going to access the next level. So we're going to see if we can do one more level. Hopefully it's not as difficult as the previous challenge. So Okay, so you receive a URL that you must visit. In the body of the URL, there is a data from the etc. password file. So this looks easy enough. Slever says, are you ending stream? No, we're not ending stream. It's just that I need to say Hacker Frogs out for my YouTube outro. And I just finished a part of the stream that we can turn into a YouTube video. So we're going to try to do one more of these, and then we're going to move on to another section of the stream. So we got another... How many? Okay, 2 hours have passed. We got another 3 hours or so of stream to do. Okay, so before we move on, what we're going to do is we're going to record the script that we wrote for the level, because we want to document all of the challenges that we do. Because if you didn't document it, it didn't happen. That's just something we say in cybersecurity. So this is level number 25. This is level 26, rather. So 26, let's paste in the script that we've created. We'll commit those changes to GitHub. And all right. So the next thing we need to do is we need to... Well, I think we can stay in this directory, that's fine. Let's rename this file. So it's level 26, we'll rename it to level 27. Also helps with social interactions with people IRL. Floppy says, imagine typing this in the terminal. That's a fork bomb, isn't it? The last time I took a look at code that looked like this, I thought it was what did I think it was? I thought it was shell shock, but it looks like a fork bomb. Which is code that will crash your computer. Okay, so let's edit this level. Okay, we got ads on Twitch, so we'll run the ads on YouTube as well. And we'll put on the birds. How about these birds? Okay, so everybody enjoy the birds. We'll be back in about 60 seconds. Just need to have a little water break. I guess now is as good a time as any to advertise the Discord. So we've opened up a Discord a few days ago, and if you're interested in joining the Hacker Frogs community, go ahead and join the Discord. Slever says, I made a fork bomb once and almost destroyed a classmate's PC. I told him not to run that file and he did. You put it in a file? I guess that's, You shouldn't be leaving that kind of code lying around. Okay, let's put the birds away. And let's start the level. Okay, everybody, this is a guided walkthrough for level number 27 from the Temperance CTF labs from hackmyvm.eu. So in each one of these levels, you need to read the mission document over here to figure out what you need to do inside the level. So it says in this mission you'll receive a URL that you must visit. In the body of the URL there's data from a etc. password file, and you must return the UID of the proxy user. So for example, they're going to give you a URL over here, and let's just try visiting the URL ourselves. So we'll do this inside the web browser. Okay, and we see this looks like typical contents from the etc. password file in a Linux system. and we have to get the UUID, or the UID of the proxy user over here. So the user ID is a number that identifies a particular user, and in this case, we need to get this. We need to send it back to the server. So how do we do this with Python? So Cypher says it was masked as San Andreas. I mean, it's no wonder the guy opened it up, because it was not it was not labeled correctly. Floppy says if once put ransomware in a hackathon project and named it don'trun.py, and I made it so it's just there, not doing anything, and it's not opened. Someone ran it. I think you all need to stop leaving malicious code in these random files. So Cypher says, where are you if it's that light with American birds? Isn't it nighttime and winter there? Cypher, where are you from? It's not nighttime in North America, and it's not winter in North America either. It's summer and it's daytime. The funniest part is that I got second place. Well, you know, congratulations. Congratulations, Floppy. Okay, so how are we going to do this? So the first thing we need to do is we need to modify the previous level script. So I think we don't have these other libraries here, but we are going to need the request library. So the request library is how Python deals with web pages. And Cypher says, I'm in New Zealand and it's midday and winter. I mean, the southern hemisphere is doing winter right now, and I'm in the northern hemisphere. So the northern hemisphere is summer, and it's daytime. Well, yeah, it's going to be daytime for the next like 3 or 4 hours. So I mean, it's kind of different. It's kind of different where I am right now. Okay, so how are we going to do this? So the first thing we're going to do is we're going to modify the code. We're accessing level number 27 here. So level number 27, and we're just going to receive the initial data from the server for the initial response from the server. So let's write that out, and then let's run the script for level number 27. Oh, okay. We also need to make sure that we're quoting out our stuff. So what we're doing here is we're taking the code that comes after this part of the code, and we're just quoting it out so that it doesn't run. We're doing this because we're workshopping the script right now to make sure that everything runs up until this point. This is a more efficient way to write your code when you're trying to get it done in steps. So we're not running the entire program all at the same time. We're workshopping it to make sure that parts of the program work before we move on. Okay, so write that out and then run the script again. No module named request. Oh, I misspelled it. So it's requests with an S. Okay, run it again. Oh, is this because we're running it in the virtualized environment? How do we shut down the virtualized environment? Let me look that up real quick. Python virtual environment exit. Okay, so the primary command is deactivate. So I just type in deactivate. Okay, so now we're not running in the virtualized environment. Okay, awesome. So we received in bytes this URL that we're supposed to visit, and so the first thing we need to do is we need to convert these bytes into a string, because the requests library handles strings. So we just need to convert the bytes into a string. Okay, so what we're making here is the URL variable this is going to be data 2, but we're going to decode from bytes into UTF-8. I'm pretty sure it is decode, but I might be wrong. Okay, so we'll print out a little message. So this is the URL converted to a string. And we'll just print out the URL. We're going to comment out everything else, and we're going to make sure that this part of the code works. Okay, so this is the URL converted to a string, so it looks like it's been converted to a string successfully. The next thing we need to do is we need to get the body of this web page. So we're just going to look this up. Python requests get response body. Yeah, that sounds about right. Okay, so request library in Python response.text. So this attribute provides the response body as a Unicode string. That sounds like what we want to do. So import requests, response equals request.get, and then this URL over here. Then print response.text. Okay, that sounds about right. So the next step we're going to do is we're going to get the URL response body. And how are we going to do that? So it's going to be request equals we'll just call it URL request. Okay, so the URL request is going to be requests dot something. What was it again? Request dot get, and then we're going to put the URL in there. And then the response body is going to be equal to URL request dot text. I think that's it. Let me check. Request dot get this. Response dot, so whatever it is, dot text. So URL request dot text, and then we can print that out. So we're going to print out as an f string something. This is the response body. Put that on a new line and then print out response body. Sliver says, why is my TikTok feed just thirst traps? I only searched gaming, UFC, army, about movies and shows. Why does TikTok do this? I think it's gonna default to certain content depending on what your demographics are. So if you're a young man, then it's gonna give you that stuff by default until you sort out the algorithm. So if you don't watch the thirst traps and you just scroll past them, then eventually the algorithm is going to sort itself out. Okay, so let's see if this works. So this is the response body. Okay, great. It looks like we got the response body, which has the password stuff. So we just need to isolate this line. So this is going to be, let's see. So Python isolate line of text according to string. Okay, so if we want to isolate the line of text according to the string, to isolate a line of text in Python based on the presence of a specific string, you can iterate through the lines in its source text and then check each line for the desired string. Okay, and then for line in this split lines, if targeted text in line, isolated dot append line. So isolated line, okay, so we want to, why are we saving this as a list? So target, we're gonna have a target string and we're gonna have isolated lines. Okay, so I mean, I guess we're gonna get the extracted line. We're gonna extract the line. Okay, so we want to isolate the line target user. So the target user in this case is going to be the proxy user. And I guess we can I guess we can put this in a list. Do we want to put it in a list? I mean, I guess we can, yeah, I guess we can put it in a list and see what happens after that. Okay, so, what is this? Slever says, you care about yourself, okay. I am Mr. Robot. Fishbone says, hi, Shy. Hi, Fishbone, nice to see you here. Let's see, Floppy says, what's the difference between big frog, round frog, little frog, and tadpole on Discord? Is it based on the question related to experience? Yeah, so if you've got, no experience means you're a tadpole. If you've got some experience but not very much, you become a little frog. If you've got some experience but not a lot of experience, you are the round frog. And if you have a lot of experience, you become the big frog on Discord. So it should give you basically a role on the Discord server. Okay, so we're going to run our for loop here. For line in response body. How come there are not many big frogs? The Discord links are safe, right? I mean, I'm pretty sure they don't have anything malicious in them. They're just used to join the Discord. Okay, so if target string in line, then isolated lines append line, okay? So let's see, in this case it's going to be target list. So if target user in line, then isolated, well, I guess we're just going to call this target list. Target list append line, and then after this for loop, we're going to print off a little message. Okay, this is the line with the proxy user. And then new line, and then print off the target list. Okay. Slever says, I made the links. Yeah, I made the links. They should be safe. Calico, nice to see you here. Welcome to the stream. Okay, so we're just writing a little Python script here. I think we're going to give ourselves another 15 minutes to finish off this level. I'm pretty sure we should be able to get it done in 15 minutes. 15, that is 1-5. Okay, 15 minutes. Let's start that clock. Okay, let's run the script again. This is the line with the proxy user. Oh, That's funny. It should. So for line in response body. So response body is the text, request.text. If target user, and target user is proxy, is in the line, then target list.append that line. For line in response body. You know what? Let's just do a little test. So for line in response body, we're going to print the line. Print line. And we'll see what happens. We will see what happens after that. Cypher says, after talk of frogs, I looked at poison frogs and was told help is available. I guess you typed in the right keyword in that case. Okay, let's run that thing again. So this is going to be, yeah, this is each character here. So this doesn't treat this as a line. It treats this as each individual character, which means it's not going to work. So for line, oh, split lines. This is the part I forgot. So text data, split lines. Okay, so I need to include this. Silly me. So, okay, let's get rid of this. So for line in response body dot split lines. Save that out. Clear it, run it again. Okay, so this is the line with the proxy user. So this is one item in a list, and we need to split this up. We need to split it up. Actually, you know what I want to do? I want to save this as a string instead of a list. So let's see, Sliver says, I don't think it will join through the links. I never click links from anybody, not even my parents. I mean, that is overdoing it. I mean, if you don't want to join the Discord, that's fine. But I mean, the link is pretty much the only way I can send the invite. Okay, so how about, I think for the string, you should be able to join the line. Target, we call this target string now. So target string join line. Or does append work with strings? Okay. Python append to string. Strings are immutable, meaning that they cannot be changed after creation. Therefore, appending to a string actually involves creating a new string using the plus operator. So the most straightforward way to concatenate two or more strings is going to be string 1 plus string 2. Okay, so in that case, so the target string is going to be empty string. So end. So target string plus equals line. Okay, so hopefully this works. If it doesn't, we'll get an error message. Target list. So target, okay, target string equals this. If target user is in the line, then target string plus equals that line. Okay. So we're actually, yeah, target, we need to do target string. So if you if you rename one variable in Python, you need to rename everything in the script that includes that variable. Okay, so this is the line with the proxy user, so this is a string. So all we need to do now is we need to isolate the number. So we know that the number is going to be the third thing when we separate this by the colons. So I think we can do this. So isolate the number. I never trust links even if they look the same. Links are my enemy. Jose Alves, hello, nice to see you here. Okay, so isolate the number. This is going to be... we'll just call this the target number. And that's going to be... This will come later. So target number is going to be some string. But this is going to be... We're going to turn this into a list. It's going to be target string dot split. And it's going to be split according to the colon over here. So the target number is going to be target list, the third element, which is number 2. And then we're going to print that print something out. I'm going to print out. Okay, so Jose Alves, how are you doing? What are we doing today? So we're just finishing off our programming assignment over here. We're just solving a level from hackmyvm.eu. So these are labs where you get to do some programming and use your Python skills. Well, you don't need to use Python. You can use any programming language you want, but you have to send specific things to the server after transforming them. Okay, so we're going to print f. This is the number we need to send back, and then it's going to be target number. Okay, so let's see if this works. So we're very close to finishing it off if we manage to get this working. Slever says, I never connect to any public internet and never answer unknown numbers or numbers that you don't know. I think that might be a little bit too too much. You have to accept some risks at some point, otherwise you're never going to get anything done. Okay. Let's run the script one more time. This is the number we need to send back, and it looks like this is the correct number. So all we need to do now is we need to convert this string back into bytes and then send it back. So convert the string into bytes over here. So bytes equals target num dot encode from UTF-8 back into bytes, and then send the challenge back, and then receive the flag. Okay? So let's see if we can get this all done in one shot. Okay, we received the flag. Awesome. Okay, so let's talk about what we did in this level here, and then we'll finish off the level. So when we ran the script, we received a URL over here. We need to convert the URL back into a string and then get the body of the URL over here. So the URL we converted back into a string. We used the requests library to get the response, the body of the response when we go to that URL. And then we extracted the line that we wanted to, which was the one with the proxy user on it. We also isolated the number inside of the line so that we could send it back. So this is it over here. This is the response. We isolated the line with the proxy user here, and then we extracted only the number. So the number, we converted that back into bytes, we sent it to the server, and then we got the flag. So HMV proxy no what? Proxy no world? Anyways, let's copy that flag and let's send it back. Okay, so we're going to submit the flag, and that is the correct flag. Okay, everybody, that was a guided walkthrough for level number 27 from the Temperance CTF labs on hackmyvm.eu. So if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so everybody, let's not call each other names. I think you have to decide for yourself how safe you want to keep yourself. And the problem is that safety comes with a lack of freedom. So you need to balance out your freedom versus your safety measures. So this is a classic problem inside of security. So if you make everything super safe, you make it very inconvenient for the people working on the project or the users. If you make safety inconvenient, then the people are not going to follow the safety protocols, or they're not going to want to work on your project. So you need to balance out safety versus practicality. Okay. All right, so let's move on to the next topic, okay? So the next topic is going to be topic number 3. So topic number 3 is reverse engineering. So we're going to learn about reverse engineering and through a free GitHub course. And then afterwards, we're going to be working on a Windows hacking machine. So let's go ahead and stop the timer. We'll put an hour on the clock, and we'll be learning about reverse engineering for 60 minutes or so. Okay, here we go. Okay, so everybody, the course that we're going to be following is over here. So it's from a user called Guy in a Tuxedo on GitHub. Tufacho, hello, nice to see you here. Welcome to the stream. You know what we haven't done? We haven't done too many video redeems. Here's a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it.
Okay, so it looks like we got ads running on Twitch, so we run them on YouTube. So I just want to tell everybody the bird videos that I play, they're from...
Where are you?
I'm system root.
So the videos that I play, they're from all times of the year. So this is a video from the winter. So enjoy the snowy birds. We'll be back in about 40 seconds. Okay, what do we got? We got some birds. So, I mean, I especially like feeding the birds in the winter because the birds really need the food in the winter. They usually can't find their own food. Food is pretty scarce, so I feel good being able to feed the birds when the weather isn't very nice out. Okay, let's go ahead and put the birds away, and we'll get back to the hacks. Okay, so let's take a look at the introduction to the course. So if you need a link to the course, well, I'll provide a link to the course one more time. There you go. We'll go through the introduction here. So this is actually a course that does both binary hacking and reverse engineering. And what does it say? So I just want to say a few things to the people who are super new to BinX and reverse engineering. If you're already familiar with assembly code and binary and BinX and reverse engineering, and tools like Ghidra, Pwn tools, and GDB, feel free to skip this whole section. So I'm assuming that people are not super familiar with BinX. and reverse engineering. So what is a binary? So binary is compiled code. So anytime you're running a program, it's actually a binary. It's called a binary because it's a program that runs with a series of numbers of zeros and ones. So when a programmer writes code in a language like C, the C code isn't what actually gets ran, it's compiled into a binary. So the C code is human readable code, and it has to be transformed into machine code before it can be run by the computer. So binx is the process of actually hacking a binary, but what does that mean? So in a lot of code you'll find bugs. Think of a bug as a mistake in the code that will allow for unintended functionality. As an attacker, we can leverage this bug to attack the binary or actually force it to do what we want to by getting code execution. This means we actually have the binary execute code that we say and can essentially hack the code. So on the other hand, aside from binx, we also have reverse engineering. So Sliver says, so if I know how to code tools, does this mean I know how to reverse anything? So, I mean, if you know, that's where it becomes a little bit complicated, because we're talking about reverse engineering. In particular, we're talking about reverse engineering x86, and x86 is a computer architecture. So x86 is most of your PCs and your laptops. Most PCs and laptops, aside from Mac OS PCs and laptops, they run x86. So x86 is a type of processor. So Apple uses a different processor. They use, is it called ARM? Okay, list of CPU architectures popular. So ARM, yeah. So Mac is ARM. So x86-64 is the chipset that most of your PCs and your laptops use. So x86-64 has its own assembly language, and it's this assembly language that we're going to be examining most of the time when we use our debugger. Okay, so reverse engineering is the process of figuring out how something works. It is a critical part of binary hacking, since most of the time you're just handed a binary without any clue as to what it does. You have to figure it out. Once you figure out how it works, you can attack it. So most of the time your objective is to obtain code execution on a box and pop a shell. If you have a different objective, it'll usually be stated at the top of the write-up. In almost every instance where your objective isn't to pop a shell, it's to get some CTF flag associated with the challenge from the binary. So what should I know before getting into the course? So there are a few areas that will help. If you know how to code, that will help. If you know how to code somewhat low-level languages like C, that will help more. So when we do binx and when we do reverse engineering, we're mostly going to be focusing on binaries that were compiled with the C language or from the C language. So we're dealing with C language, we're dealing with x86 architecture, but reverse engineering and binx can be other languages, and it can be other CPU architectures. Okay, so why CTF challenges? The reason why I went with CTF languages to teach binx and reverse engineering is because most of the challenges contain a small subset of hacking knowledge. So for each one of these challenges, you're going to be introduced to a concept. It's usually not going to be super complicated, but hopefully it's new enough and it's bite-sized enough so that you can understand what's going on. So with that, I can split it up into different subjects like buffer overflow into calling shellcode or fast bin exploit hacking, so it can be covered like a somewhat normal course. So in the environment, for your environment to actually do the work, we would recommend having an Ubuntu VM. However, don't let me tell you how to live your life. So, I mean, we're going to be using our Kali VM as the environment where we do the reverse engineering and the binx stuff. So why should I do this? So first off, if I find it fun, if you don't find this fun, I wouldn't recommend doing this. Plus, there's a whole lot of jobs out there that do this work with not a lot of people to do the work. Plus, who doesn't want to drop that Chrome 0 day and watch the world burn? Let's see. Floppy says, opinion on REM Nux. I think I think it's a pretty cool VM. So Remnux is a reverse engineering VM. Remnux. So yeah, it's basically it's a virtual machine that you can download and deploy, and it has a lot of tools for malware analysts. So malware analysis, reverse engineering, binary hacking. It's pretty cool. Aqua says, finally starting on Nightmare. I'm going to follow along too. Thanks. I mean, I'm not especially that great about reverse engineering and binary hacking, so I need to figure this out because eventually I want to be able to teach a course on this stuff. So the first part is educating yourself. So teachers need to learn the material before teachers can teach the material. But yeah, if you want to take a look at the Remnux virtual machine, here's the link. Okay, where were we? And if you want to learn about reverse engineering and binary hacking, this is another great place that you can learn about the stuff. Pwn College. Unfortunately, they don't let people who do live streaming or YouTube videos cover their stuff. Otherwise, we would be all over this stuff because it's really good. But back to Nightmare. So difficulty curve. One thing I want to say is that the difficulty curve, in my opinion, is like a roller coaster that goes up and down. There are certain parts that are easier and certain parts that are harder. Granted, difficulty is relative to the person. So I would say that if you're not coming from a background where you understand low-level programming and you don't know how to look at assembly instructions in a debugger, it's going to be kind of difficult. But, we'll try to help you out as best we can along the way. Floppy says, I really recommend Remnux. I don't even use Kali for reverse engineering and Binax, just Remnux. I mean, we're going to try to muddle our way through with Kali Linux. We'll see how far we can get before we get stuck. But yeah, Remnux is pretty cool. Okay, so introduction. Next, we're talking about assembly. So assembly is, you need to know assembly if you want to interact with reverse engineering and binary hacking. Because assembly language is what you see when you disassemble or take a look at the binary instructions in the disassembler or the debugger. Saying for the future, not at this exact point in time. I think, yeah, eventually we might be switching over, but there's a good course for teaching people about assembly language or how to code in it, and it's called the ASM Tutor. ASM Tutor, I think it's .com or asmtutor.com. Here we go. So this course over here teaches you how to write very simple programs using assembly language instructions. Okay, so for example over here, this is what it looks like when you code inside of x86 assembly. But we'll kind of skim over the assembly instructions as we run into them. You don't necessarily need to understand everything right away, but you will need to study this eventually, otherwise you're going to have a bad time. Oh, Calico, yeah, you're interested in reverse engineering. I remember you talking about it on the Discord. But this is a very good site for learning about the instructions. Okay, where were we? So compiling. So first off, what is assembly code? So assembly code is code that actually runs on your computer by the processor. So I mean, this isn't exactly correct, but this is the lowest level language before the actual machine code that runs on the computer. So I'm pretty sure that this is the actual machine code. And well, this is hex interpretation of the machine code that runs on the computer. And these are the English language, well, the actual code that is going through. Aqua says there's a Shy Hat Discord server. Yeah, we've got a Discord server now. Let's give you the Discord. There you go. So that code isn't ran here. Yeah, so the example here is that the Hello World program, if you compile this from C language, it's going to turn into this assembly language over here. So it's going to move a bunch of information into the different memory registers, and then it's going to load up the string that it's going to print out, and then it's going to make a call to print out the message, and then it's going to exit from the program. So the purposes of languages like C is that we have to program without having to deal with assembly code. When we write code that is handed to a compiler, the compiler takes the code and generates assembly code that will accomplish what the C code tells it to do. So basically, we use a compiler program to turn the C code into the code that's actually run by the machine. So however, we have tools like Ghidra that will take compiled assembly code and give us a view of what it thinks of the C code might have looked like. So Ghidra is a pretty powerful program. It does, what is it called? Decompilation instead of disassembly. So most of the time when we take a look at when we take apart a binary, we're looking at disassembly, which is the assembly instructions inside the binary. But if you use a program like Ghidra, you can actually decompile the assembly instructions, and it'll give you a guess at what it thinks the C code might have looked like. So also with assembly code, there's a lot of different architectures. Different types of processors can run different types of assembly code architectures. So most of the time we need to pay attention to the 32 versus 64-bit chips. Most of the time we only use 64-bit CPUs. But maybe 20 years ago, or 20 or 30 years ago, 32-bit processors were much more common. And Floppy says you can decompile bin files on dogbolt.org for quick jobs and small files. Yeah, so I think this is actually a great resource. I should probably put this in my BinX and reverse engineering resources, the educational resources. So it's this is the link that Floppy sent over here. So basically what you can do is you can upload a file. So I think I've got a Hello World file sitting around on the computer here. So I think, let me see, temp directory. Oh no, I didn't. Okay, you know what? I'm gonna compile a quick program right now. So where is it? Okay, so we got our Hello World here. For some reason, I don't think that this Hello World is gonna work. Just a second, I'm gonna grab something from my own website. Just a second. Okay, so where are we? So Hacker Frogs, I'm trying to Hacker Frogs after school. This is reverse engineering. I was writing a little article over here. So this is the Hello World program. We're going to compile this. So to create it, it's pretty easy to compile. Oh, let's get out of this directory. So we're just going to create a file called hello.c. So this is all it's going to contain. So it prints out Hello World, and then it exits from the program. So we're just going to save this. We're going to compile it. Floppy, well, you know what? let's keep mental health a big part of the stream. Let's all have healthy minds. All right, so we're going to use GCC to compile this hello.c file into a binary called hello. So the hello program, all it's going to do is print out hello world. So if we just run hello, it prints out hello world and it exits. So we're going to go over to the decompiler explorer here, and we're going to upload the program we just compiled here. Yeah. Okay, and we should see in just a second how it decompiles this. Wow. It sure does give you a lot of... Okay. So the thing about decompiling these C programs is that all of the built-in C functions are also included in the program because it needs to use those. I'm happy now just writing it so that okay. Don't be sad, everybody. But yeah, this is a pretty cool resource over here that you can use to do some reverse engineering. But anyways, let's go back. So the next thing we need to talk about is registers. So registers are essentially places where the processor can store memory, and in your processor there's a bunch of memory registers which the CPU can use to store data. So little bits of data which it can access really quickly. So in most of the time we're using 64-bit registers because we're dealing with 64-bit programs. So when we take a look at 64-bit programs, we've got, well, all of the registers are prepended with the word R, and in 32-bit programs, all the registers are prepended with the letter E. 23R, or is that 0? Let me know if it's 0. Thank you very much, and welcome to the stream from YouTube. Let's give you a Nyan Cat. Welcome in. So there are special registers that we'll be talking about over and over again, like this one over here, the base pointer. So in 64-bit architecture, it's RBP. So the base pointer points to the bottom of the current stack frame. So the bottom of the memory stack is the RBP pointer. There's also the stack pointer, which is the SP or RSP, which points to the top of the memory stack. It's 0. Awesome. Okay, there's also the IP or instruction pointer that points to the instruction that's to be executed. So we're going to be talking about these registers pretty commonly when we do reverse engineering and binary hacking. But there are all sorts of memory registers that are part of the x86 system. So there's AX, there's BX, CX. So most of the time, you can ignore the X and the first letter and the last letter. You can ignore those most of the time. So this is just the A register, the B register, the C register, the D register, or the S index, the D index, and a bunch of other memory registers over here. Okay. So in x64, Linux arguments to a function are passed via the registers. So the registers are used in a very systematic way, where if you're running the same commands over and over again, you'll put arguments to the command in the different registers, like the D register, the D index, the S index, the D register, the C register, etc., etc. Okay. So another thing we should keep in mind is that there are different sizes for the registers. So most of the time when we're talking about 64-bit registers, 64-bit registers each register is going to be 8 bytes. So 8 bytes is usually 8 characters, or like a 2-digit decimal, a 2-digit hexadecimal number. So within the RBP register, for example, you also have the EBP register. So RBP is 8 bytes. The latter half of the RBP register is the EBP register, which is 4 bytes. So 8 bytes, 4 bytes, and then we've got the lower registers, so which is the first and second halves of the EBP register. So the BP register and the BPL register. So it's just finding a way to segment all of these memory registers into little portions. Okay, so at any point during the conversation here, while we're trying to work through the course, if you have any questions, feel free to ask the questions. You can also try asking the questions to the AI. The AI is actually very good at explaining concepts like low-level programming and CPU architecture. So for example, if I were to ask it something like, what is the EBP memory register in x86? It can answer these questions pretty well. So it's a 32-bit memory register used as a frame pointer in a stack-based function call, okay? And if during its explanation here there are any terms you don't understand, you can keep on asking those questions. I mean, the great thing about using the AI to answer your questions is that the AI will never call you stupid for not knowing any terms here. Whereas if you ask actual people, they might look at you funny and it's like, why don't you know this? Why do you not know everything? Why are you dumb? But the AI will never call you dumb for not knowing about something. So that's why a lot of people turn to AI when they're asking their questions, because they don't want to look dumb. Nobody wants to look dumb in front of other people. Anyways, let's move on. So words. So words are 2 bytes of data. D words are 4 bytes of data, and a quad word or Q word is 8 bytes of data. Okay, and then we're talking about the stack. So the memory stack, we're going to be talking about this a lot. And the stack is basically a place where you can store different pieces of data. So one of the most common memory regions you're going to be dealing with is the stack. And the stack is where local variables in the code are stored. So for example, in this code, variable x is stored on the stack. So we got an integer called x, it's equal to 5. And then we print high. So specifically, we can see it's stored on the stack at RBP, so the base pointer minus 4. So when we say RBP minus 4, it's this memory register here, and then it's minus hex 4 in the memory addresses. So for example, let's see, where are we? Okay, so it's stored on the stack behind the base pointer. So the base pointer is the memory register that points to the bottom of the stack. This is stored behind it because it's negative hex 04 in the memory address. Values on the stack are moved on to it either by pushing them onto the stack or by popping them off. So you're going to see these two instructions a lot when you're doing reverse engineering, pushing and popping. So pushing is putting something onto the memory stack, and popping it is removing it from the memory stack. So this is the only way to add or remove values from the stack, and it's a LIFO data structure. So LIFO stands for last in, first out. So the last thing that you put on top of the stack is the first thing that's going to be removed if you remove something from the stack. So we can reference values on the stack, which means we can point to different values on the stack without actually moving anything on the stack. The exact bounds on the stack are recorded by 2 registers, the RBP and RSP. So the base pointer is the bottom of the stack, and the stack pointer is the top of the stack. Okay, so there's one register that contains flags. A flag is a particular bit of this register. It is set or not, it's going to be something. So the flags here are basically, they're little memory locations that can be set to either 1 or 0, true or false. And this controls a lot inside of the programs. It basically, a lot of the time you can check whether or not these flags are set to specific values, and then you can do something based on the value inside of the flag. Floppy, I keep on saying Flappy for some reason. But Floppy, thank you very much. Okay. So instructions. We're going to be covering some of the most common instructions you see. This isn't everything you're going to see, but these are some of the common instructions. So we're going to see this one all the time. It's the move instruction. So move instruction just moves data from one register to another. So move RAX RDX. So this will move data from the RDX register to the RAX register. So most of the time when you see these instructions, when you see the move instruction here, the first thing that's listed after the move instruction is the place that is going to be affected. So this memory register will be written to, and this is the information that's going to be written to it. So whatever's in the RDX memory register is going to be written into the RAX memory register. Okay, there's also dereferencing. If you ever see brackets like this, they're meant to dereference, which deals with pointers. A pointer is a value that points to a particular memory address. It is a memory address, and dereferencing a pointer means to treat a pointer like the value that it points to. For instance, move RAX dereference RDX. So dereference RDX means it's going to put the memory, let's see, this will move a value pointed to by RDX into the RAX register. So the value that is referenced by RDX, so it might have a particular value, it's going to be moved into RAX. On the flip side, move RDX, the value of RDX, into the reference of RAX. It's going to move the value of the RDX register into whatever memory is pointed to by the RAX register. So the actual value of the RAX register does not change. So this can be a little bit confusing, but if you do some experimentation with it, then it should become more easy to understand. Okay, we got the LEA, or the load effective address. This is an instruction that calculates the address of a second operand and moves that address into the first one. For instance, load effective address, this into RDI. So whatever information is at RBX plus hex 10 is going to be loaded into the RDI register. It's going to move the address. Oh, okay, so this is the address. The address is going to be moved into the RDI register. And we've got some easy instructions to understand here. Okay, we got an ad running on Twitch, so we're running on YouTube, and we'll put on some birds. So how about these birds? We'll be back in about 20 seconds. Okay, we'll put the birds away. We'll get back to the hacking. So the next two instructions are pretty easy to understand. This one is add. So it adds the two values together and stores the sum in the first argument. So for example, we got add RDX RAX. So this will set RAX equal to RAX plus RDX. So we got sub. So the value will be subtracted from subtract the second operand from the first operand. So this value over here, RSP, the stack pointer, is going to be, we're going to subtract this value from it. So it's hex 10. So this will set the RSP register equal to RSP minus hex 10. Okay, we've got an XOR operation. So XOR operations are bitwise operations that are going to modify according to the binary operation. So XOR operations are pretty... Let me illustrate what an XOR operation is really fast. Okay, so XOR operations are bitwise operations. Say you've got a binary number. Say we've got this binary number, and we've got another binary number. So say we got something like this. So if we do an XOR operation between the two, then what we need to do is we need to compare the bits in the same column, and if they're the same, then we put down a 0, and if they're different, then we have to put down a 1. So in this case, we take a look at the first two bits in the column, it's a 0. We see these columns over here, they're different, so we put a 1, and this one is also different, and this is the same, and this is different, this is different, this is different, this is different. Okay, so whenever you do an XOR operation between two binary numbers, Soto says, I'm late. No worries, no worries. You can always go back in the VOD and you can take a look at the stuff that happened earlier, or you can watch after the stream is over, or you can watch over on YouTube where you can rewind the stream. There are many options available to you. So basically an XOR operation is going to modify the contents according to a binary operation. So to do a binary operation, you need to convert whatever numbers that are involved into their binary equivalents and then do the operation. And you don't need to know too much about this, except for the fact that the XOR operation can happen inside of assembly instructions as well. So one thing that is pretty common in assembly instructions is XORing a register by itself, or if you XOR... So for example, if you XOR RAX with RAX, then you're going to get a result of 0, 0. Well, basically, you're going to get 0 as your result. So if you go over to XOR any number by itself, say we've got this number over here, and we XOR it by the exact same number. So the result of the XOR of a number by the same number will always be zeros across the board. Because when you XOR, if the numbers are the same, you put down a 0. Flappy says it's also a good encryption method if you add more complexity to it. Yeah, if you deal with cryptography, you're gonna see the XOR operation a lot, especially when you're dealing with public key encryption. But XOR is one of these concepts that you have to understand to grasp like more advanced computer concepts. Okay, so most of the time, sometimes you'll see this character over here to represent the XOR operation. So this means RDX XOR RAX. So the AND and the OR operations essentially do the same thing, except with the AND, or binary operators. So AND and OR are also binary operations that you'll see done inside of assembly instructions. So the next two instructions you need to pay attention to, because these come into play a lot. So the push instruction will grow the stack by either 4 bytes for 64-bit programs, or 4 bytes by 32-bit processors. So 64-bit processors will increase it by 8 bytes, and 32-bit processors will increase the stack by 4 bytes when you push. they push the contents of the register onto a new stack space. For instance, this. So push RAX means that the RAX register will be, well, the contents of the RAX register will be pushed onto the stack. So it'll grow the stack by 8 bytes, and then the contents of the RAX register will be on top of the stack. So the opposite is the pop instruction. So the pop instruction will pop this top 8 bytes, or the top 4 bytes, off of the stack and into the argument. So this will shrink the stack. For instance, pop RAX means take whatever's on top of the stack and then put it into the RAX register, and that's going to remove the contents from the stack. So the top 8 bytes of the stack will end up in the RAX register, and then we've got jump instructions. So, I mean, if you were here at the beginning of the stream, I was playing a game called Human Resource Machine, and we used jump instructions all the time. So the jump instructions are going to jump to an instruction address. It is used to redirect code execution. For instance, you've got jump over here, and this is what is called an unconditional jump. That means that the jump is going to happen all the time, no matter what, and it's going to jump to this memory address over here. So after it jumps there, it's going to execute whatever instruction is in this memory address. Okay, so we got the call and ret instructions. So this is similar to the jump instruction. The difference is it will push the values of the RBP and the RIP onto the stack, then jump to whatever address is given. This is used for calling functions. So whenever we call a function inside of the inside of assembly, we have to use the call instruction. So the call instruction is going to call a function, and the ret instruction is going to return from the function back into regular instructions. So after the function is finished, a ret instruction is called, which uses the pushed values of the RBP and the RIP, and which are the saved base and instruction pointers, and it can continue execution wherever the function was called. So call basically is going to redirect the program flow into the function, and then after the function is over, it's going to return back to the regular program execution. Okay, so we also have CMP, which is compare. So the CMP instruction is similar to that of the sub instruction, except that it doesn't restore the result in the first argument. It checks if the result is less than 0, greater than 0, or equal to 0. Depending on the value, it will set flags accordingly. So the CMP instruction is a comparison. So it compares the value in a memory register, and it will note that if it's less than 0, greater than 0, or equal to 0. So if you were here at the beginning of the stream and we were playing Human Resource Machine, this kind of instruction also appeared in that game a lot. Okay, so we got the last couple of instructions we have here are JNZ and JZ. So JNZ is jump if not 0, and JZ is jump if 0. So jump if not 0, jump if 0. These instructions are pretty... Nixie! Thank you very much for subscribing, Nixie. Let's give you a fun video redeem. How about all the things? Drink all the booze and hack all the things.
This one's dedicated to all the hackers. Yo.
So the thing we have to understand about these two instructions, jump if not 0, jump if 0, is that they're usually done immediately after a comparison. So the comparison for something is done, and then it checks to see if that comparison is 0 or not 0, and it'll jump if it is not 0 or if it is 0 accordingly. So it will only jump if the 0 flag is set. The opposite is true for a jump non-zero. Okay. So we finally finished with our assembly instructions. So next we're going to be talking about assembly reversing problems. So there are some basic assembly reversing problems over here. And the purpose of these challenges is to get some experience reversing assembly code. Try to figure out what the binaries are doing to view assembly machine code into to view assembly machine code into assembly code, you can use something like object dump. Okay, so I guess we can just take a look at this ourselves. So if you want to take a look at what I'm looking at, this is it right here. Okay, so after searching for the string main, for the main function, we see this. So we've got a bunch of assembly instructions: load effective address, and push, move, subtract, push, call, a bunch of different stuff. So looking at the code, we see a function called to puts. So call puts. So this is actually a function call that does the, what is it called? The printf C function. So the printf C function, if you take a look at hello world, so we got our hello world program over here. I like to use the Radare2 disassembler. We're just going to take a look at it. And then we're going to take a look at the instructions in here. So we can get all of the functions in the program by doing this command over here, AFL. And if you're wondering how to use the Radare2 program, I think I've got a little crash course in, let's see, binary hacking. Okay, Radare2 Beginner's Guide. So if you've ever wanted to, you know, understand like some basics of using the Radare2 program, this is the guide over here. Okay, so what we want to do is we want to take a look at the contents in the main function here. So we would do print disassembly function, so PDF at main, to take a look at the instructions in the main function. So this is printf. So printf makes a call to puts. So before we make a call to puts, we have to set some stuff up. Essentially over here, we've got a string called hello world, and we have to load the string into the RAX register. After we do that, we have to move the RAX register into the RDI register, which I'm not exactly sure what, I mean, no, this is just how it works. So you have to move the string into RAX and then move it from RAX into RDI, and then you have to make the function call. Floppy says, I feel like Radare is an overcomplicated GDB. I know it's not. I mean, GDB is okay, but there's a lot of stuff that you can do instead of Radare2 that you can't do with GDB. There's extra functionality in there, and that's why I like using it. Okay, so what are we identifying here? So we see a call to puts. So call, puts, push, something, something. So looking through the rest of the code, we don't see anything else as interesting from our perspective. So the code is probably going to print a string. When we run the binary, what we see is hello world. Okay, sure. So, you know what? I want to take a look at the GitHub repository that they're referencing over here. So Floppy says, I use Radare2. That's just how I felt when I started doing Rev and Binax. No worries, no worries. What is this? Wait, is this a binary? Oh, it is a binary. Okay. So I mean, yeah, okay. So I mean, we downloaded the thing. Maybe we can take a look at it. Okay, so this should be a yeah. So this is a 32-bit program, so we can make it executable. Here we go again, downloading random executables and then running them. So this should be so it's x equals 10. Is this the exact program we were looking at in here? No, I don't think so. Okay, no, this is it. Okay. So if we start off by viewing the assembly code with object dump. So object dump, this will let us see the code that is being, well, the assembly instructions. Okay, and then, yeah, and we can also scroll up and down. Okay, so what do they want us to do? So it looks like it loads the value 0 hex A. So 0x means hex, hexadecimal. So we can read this as hex A into EBP minus hex C. Immediately preceding that, we say that it runs a comparison instruction to check if it is equal. If they are not equal, it will jump to main plus hex 2e. Since it was just loaded with the value hex A, it should not make the jump. Okay, preceding that, it should make a call to puts. After looking at the code, we see that it should make that puts call. When we run it, we see what it does. So if then, x equals 10. Okay, so we can actually take a look at this in our disassembler. So Radare 2. Okay, we'll analyze the binary here using Radare, and we should be looking at the main function. So PDF at main is going to print off the instructions in the main function. Okay, one thing that's really nice about the Radare 2 program is that they do a lot of syntax highlighting, which means that we don't get one monochrome number, or sorry, monochrome color when we look at this stuff. It makes it a lot easier to read. So it looks like we see the string that is being printed out over here, x equals 10. So it pushes the string x equals 10, and then it calls puts. So if you remember, puts is the printf. So push and then call printf. It also does some comparisons. So it compares. Siva says, "Hi brother, how are you?" Hi Siva, nice to see you here. We're just learning about reverse engineering and low-level stuff. Welcome to the stream, and let's give you a Nyan Cat. Okay, so what do they want us to notice over here? So after looking at the code, we should say that it makes the puts call. When we run it, we see what it does. It just prints out x equals 10. So let's take a look at the assembly code. So is this a function inside of the if then? So another thing that we can do is we can take a look at all of the different functions in the binary by using this command over here, AFL, which stands for all functions list. So are we looking for a loop in here? I don't think we are. So what is the loop that we're referencing in here? Okay, so there's some basic assembly reversing problems from this repository. Let me take a look over here. We'll just go one level up, and maybe they're the other binaries if we go a level up. So there's only one. So this challenge is if then. Yeah, okay. All of the different binaries that they're referencing in the course are over here. So I'm figuring this out at the same time you all are. So the great thing about this is that you can actually download the binaries here and then you can run them yourself. Just so you don't have to rely solely on whatever they're presenting in the course. So over here, we're going to get this file, download it. Okay. So this is the loop program here. So for each one of these programs, we need to make the program executable before we can run it. So over here, we've got, when we take a look at the file permissions, if we see the X over here, that means we can execute it. Otherwise, we can't execute it. So to make a program executable, it's pretty easy. We just need to run the chmod plus X command. So chmod plus X on loop, and then we can run the program. So it looks like the loop program is, it's counting the numbers from 0 to 19. This is actually 20 numbers, but since they're starting from 0, it stops at 19. Okay, so let's take a look at the instructions here. So we can Radare 2, and we're looking at the loop program this time. So we can analyze the binary with the AAA, and then we can take a look at the main function. So it's PDF at main. And this is the loop over here. So the loop is going to be, I guess what I'm guessing is that it's iterating over a number, and then it's running a bunch of stuff over and over again, and it's going to print each time. So Siva says, I want suggestions. Start content creation. What? I want to start a content creation channel? You want to start a content creation channel on hacking? Live hacking or videos, which is better? I mean, I think what you should do is you should do live streams, and while you're doing your live streams, you can do your demonstrations, and then you can take your live streams, you can cut the live stream video, and then you can turn that into something you can put on YouTube, for instance. I mean, that's how I do it. X says, I know some code programming, but I need to ask ChatGPT to remember it. Well, X, are you talking about which language are you coding in? Are you coding in Python? Or are you coding in assembly? Or are you coding in C? If you have to ask ChatGPT, I mean, asking ChatGPT by itself is it's not a bad thing, as long as you're learning from what ChatGPT is telling you. If you're just asking ChatGPT to write the code and then you run the code, you're not learning anything. But if you use ChatGPT as a tool to try to understand what exactly is going on in the code, then that's not such a bad way to use the AI chatbot. Okay, so each time it runs through the loop, it's going to. I'm thinking that it runs over and over again until it hits a certain number, and okay. So it's comparing it against a number here. and the number is hex 13, and I'm guessing hex 13 is the number 20. So 16 plus. So the 1 is 16, and the 3 is 3. 16 plus 3. So it's 19. Oh, okay. So if it reaches 19, then it's going to jump out of the loop. So it'll jump less than or equal, and then it'll finish off the program. Otherwise, it's going to go through the loop, and it's going to print out the characters over and over again. And we see that when we run the program. Where are we? So we run the loop program, and it just prints out numbers over and over again. X says, so what? So what? I'm not too sure what your question is. If you if you can be more specific about the question, maybe I can answer it. Thank you. Okay, let's look back over here. So we went through hello world, if then, loop. So we find the loop, I guess. So in this function, we'll see that there's this stack variable initialized to 0. So EBP is initialized to 0, then we jump over here. So we see this. So PTR. Okay, so it compares the stack value at this against hex 13, which is 19. And if it's less than equal, then it will jump to here. And then it'll bring us to a printf call. So it's going to make the printf here. So it's printing out the contents of this in some sort of format string. And then we can see that it increments the value of hex C before doing the comparison again. So add pointer, and we add 1 to the pointer over here. So putting all the pieces together, we're probably looking at a loop that will run 20 times and then print the iteration counter each time. Something that looks similar to this. So I mean, we can copy this code here. And we could, well, I mean, I guess we're not going to do that. It's going to take too much time. We could just copy this and, compile a little C program ourselves, and then see if it looks similar. Anyways, we've got ads running on Twitch, so we run it on YouTube. And then let's put on some birds. Okay, so here's a happy squirrel. We'll be back in about 60 seconds. Just need to have a little water break. Okay, it looks like we've run out of time for the topic. Okay, so I mean, this is the end of the section anyways. So reversing assembly. Okay, so the next time we do this, we'll be picking up from the next section, reversing with Ghidra. And yeah, so I mean, the important thing is that if there's anything we don't understand about anything we see, we could try asking the AI about any of these details, and we should be able to get some answers. So the important thing is that you don't feel, even if you feel frustrated, you can get the answers. You just need to know how to ask. So along with this course over here, I also recommend the courses from Pone College. So they've got a reversing course over here, and I think I've included it in my learning resources. So where is it? Okay, education resources, reversing. So if you're interested in learning more about reverse engineering, definitely take a look at the links in here, and yeah, try it out for yourself. Okay, so we're gonna do the next topic. The next topic, we'll try doing it for, we'll try 120 minutes, and we'll see what's going on after that. Because this is the last topic of the day. We're gonna be over at TryHackMe. Where are we? We're gonna be doing the soup ED code. Soup ED code 01. So this is a Windows hacking challenge. If you want to join along with us, this is a free challenge that you can do from tryhackme.com. And what we're going to do is we're going to access this. We're going to access the challenge via their VPN. So let's see. Do I have my VPN key here? No, I don't think I do. I think I need to download a VPN or a VPN key. So for TryHackMe, you can download a VPN key to access their machines on their network. And I'm going to go over to Access. Then we're going to do US East Regular. We're going to download the configuration file. And that's going to be the VPN key. So the Shyhunt, OpenVPN, OVPN, okay. And let's run that. Run the program with the key. So we're just going to do sudo OpenVPN, and I think it's my username. Okay. So we should be connected to the TryHackMe network now. So we're just going to go back to the machine, or the room rather. We're going to start up the machine, and then we're going to be able to access the machine in just about a minute or so. Oh, I need to change the topic. Okay, so we're not doing topic 3, we're doing topic 4. Okay, so, well, we'll see the IP address for the machine in just a minute, and I'm going to take this opportunity to reset my terminals. So the terminal's over here. Yeah. I usually like to work inside the temp directory when I'm doing the CTF challenges, or the CTF box challenges, because, well, I want everything to disappear after I'm done with the challenge, because you're usually gonna collect a number of files, and I don't want those things to be hanging around. Okay. So the first thing we do when we do one of these CTF box challenges is we do an Nmap scan. So we do an Nmap scan to scan for open ports on a remote server, and the remote server is going to be at the IP address shown over here in just a second. This one here. Okay. So we're going to go to our port scanning tab. We're going to run Nmap. And the first thing we're going to do is we're just going to get the port numbers. We're just going to run the port numbers. We're not going to run scripts on whatever we find. Okay. That's not the right IP address. Okay, so we got, yeah, so this looks like an Active Directory machine. So Active Directory will usually run specific ports, in this case 53 for DNS, and then 139 and 445 for SMB, 339 for, I'm not too sure what 339 is. I think it's, is it MS SQL? 3389. Let me check really quick. 3389. Oh, that's RDP. Okay. MC25. Thank you very much. Let's see. TCP port. Yeah, Remote Desktop Protocol. So this is how you remotely log into a computer. with the graphics interface. So if we're able to find a user with RDP access, we could potentially log in with a graphic user interface. Okay, we've also got 88. So 88 is Kerberos. So Kerberos is what Active Directory uses for authentication. We also have... Man, I should know about these ports. So there's 839 and 464. 9389. These look kind of random, but I'm pretty sure they're well-known services on these port numbers as well. So what we're going to do after we get the list of port numbers is we're going to run some common scripts and some versioning information against them. Another thing that we very commonly see when we scan against Windows targets is we see a bunch of ports in the 40,000 range, like these over here. So these are usually running, oh, what are they called again? So these are various services that the Windows operating system uses. Okay, so while we're scanning against this, we can also start scanning some other services as well, because we know that there is SMB open on the system. So SMB is port 139 and port 445, and we use a very common Windows testing tool to scan against this service, which is called netexec. So netexec is, we run netexec like this. We have to specify a protocol and an IP address, and then we try to figure out if we can access the system without a password. So most of the time we won't be able to, but sometimes we can. So status access denied. So the name of the computer is DC01. So that's pretty common because this is an Active Directory environment and it's the only machine we have access to, which means this is going to be the domain controller. So the domain is soupedcode.local. We're going to be using this in some of our commands, so we need to take note of this. So, I mean, we might as well keep track of this in notes. So echo some stuff to notes.txt. For example, this information. And I guess we can also put in DC01 as the name of the computer. Okay, so another thing we want to do is we want to figure out if there's the guest account enabled on the system. So we're just going to put in guest as our username and see if this works. So a lot of the time the guest account is going to be disabled, but this time it looks like the guest account is enabled. So from here, we can try to see if there are some user shares that are available to the guest user. Okay, and do we get... Yeah, it looks like there are... Well... There's usually not very much inside of this file share here, IPC. And Tinako there, thank you very much for following on Twitch. Let's give you a fun video redeem. How about good old Hack the Planet?
Hack the planet! Hack the planet! Shut up again!
Okay, so let's take a look and see if we got anything back. So we got all the stuff back over here. And we also identified, so we got LDAP. Okay, I mean... There isn't too much that's super surprising about both the ports over here. But I guess we can keep on enumerating the SMB service. So there's a backup directory. We don't know who has access to it. The guest user does not have access to it. Thank you very much. 3 Eternal Oblivion. Thank you, Eternal Oblivion. Thank you very much for following on Twitch. Let's give you a fun video redeem. How about a desert frog? It's the cutest frog in the world. Okay. So if we have a valid user account, in this case we've got the guest account, we can start enumerating for other stuff. So we could start enumerating for users to see if we can discover some other users on the system. Eternal Oblivion says, "Hey man, I just joined. I like your content." Thank you very much, Eternal Oblivion. Thank you. Looks like we can't get users. How about we try doing the rid brute technique? So this is also going to get us some users. It uses a slightly different technique. We might or might not be able to find some stuff this way. Okay, so we managed to find some... Wow, that's a lot of users. Which ones are legitimate? I mean, admin is probably a legitimate user. Backup SCV, web SCV, monitoring SCV, and a bunch of... Yeah, okay. So many users, yep. Okay, so I think... Man, that's a lot of users. Hold on, let's see if I can go up to the top. Let's... This is too many users. I think we can start from here. So this is where the legitimate users begin. So everything before this, these are groups. So we're just going to grab everything from here. And we're going to find a way to format this correctly. Okay, so nano users.txt, we're going to paste in all this stuff, and then we're going to use some Linux foo to only get the names of the users themselves. So we only want to get this section over here. So we're going to do, what is it? Cut by division, and the division is going to be the backslash. And we only want to get the first, we only want to get the second field. So -F2. So this should get us everything after the slash. Okay, so this gets us everything after the slash. We need to refine this a little more, because we want to get rid of the SID type user. So we're going to cut again, and we're going to divide it by this character, the opening parentheses. And we're only going to get the first field. Okay, so this looks a little better. And the next thing we want to do is we want to get rid of all the trailing spaces. So we do a tr/d, and we're going to delete all the spaces. So that deletes all the spaces. The next thing we need to do is we need to redirect that into a different file. User, let's just call it usermod.txt. And now we've got only what we want. So we can use this as a users list, and then we can start doing some brute forcing attacks if we wanted to. I don't think we want to do that right away, but I don't know. How many lines is this? So we can find out really quick with the word count. So this is 1,068 users. So doing any sort of brute forcing is going to be very painful because there are just too many users to deal with. We could do some password spraying attacks, which means we test one password against all the users, but we don't know what we would use for a password spray yet. Okay, so what do we do from here? I guess what we can do is we can run some common scripts against all the ports that we found here. We'll just have that running in the background. We have users. We've got users. There is LDAP. We could try scanning against the LDAP service. I really haven't done very much LDAP testing before. The other thing we could do is we could start testing the system for common SMB vulnerabilities. So common SMB vulnerabilities like Eternal Blue, or maybe okay, so it's MS17 something something. Let me look it up really quick. So NetExec, another good thing about NetExec is it's got a lot of support. It even has its own wiki. So we can go to NetExec wiki. We can look up something like, I don't know, modules. So modules are basically running specific types of security tests. Okay, so using modules. So we could look for running multiple modules. Yeah, we can run multiple modules at once. Oh, you know what? There's a very common technique we could do. We can test to see if any of the users are using their own username as a password. So this is a pretty common test that we do. So we'll just do usermod.txt as the user list, and we'll use usermod.txt as the password. And what do we need to do when we do the spray? There is something that we need to tack on to the end. No brute force. Okay, so it's not no brute force. It's something similar. Okay, so let's see. I think it's password spray. Password spraying. Okay, it's password spraying without brute force. So -- no brute force. Okay, so that's what we got to do. Okay, and we also have to continue on success, I think. Continue on success. Okay, and well, this is going to take a little while, but ooh, we got a hit. We got YBob. Okay, cool, awesome. So we've got legitimate credentials now. So if we have legitimate credentials, we can do a lot more testing. We also have these guest accounts. The guest accounts really don't matter all that much. But we do have these credentials ready over here. So ybob, ybob. We're just going to copy that. We're going to put that in our credentials list. Did you do the soup? Did I do this box already via THM? Well, I mean, this is THM. We're using THM right now. So this is what we're doing. If this is like a copy from another website, I'm not sure. I have done boxes by the same creator before, so I do recognize this the name of the machine here. If this is actually like an exact copy of another machine by the same creator, I'm not too sure about that. But we can record this. So echo this to creds.txt. Okay, and then we can start doing some more testing after this. So we'll just leave this running for a little bit. Neem says, I'm saying, are we doing the THM portion of the schedule or did I miss it? Yeah, this is the THM portion of the schedule. We've got an hour and a half to do the box. Hopefully we can do it in an hour and a half. If not, then we'll see what happens after that. This is the THM portion of the schedule. So if you take a look at the current topic up at the top of the screen, you should see that, yeah, that's what it says, THM soup decode. I think this is the only set of credentials we have here. So, I'll just leave this running for a little bit. I'll run another netexec over here. We'll call this netexec 2. Okay. And what are we doing? So ybob something something. Username password. ybob 317. Okay, let's see what shares ybob has access to. Oh, that's not the right IP address. Silly me. Okay, let's... Yeah. Okay, so this is the IP address. We're going to run the command one more time. But we're going to record this in a file called, I don't know, password spray. .txt. And I think we're gonna... Yeah, okay, so we'll just save the output to a file, just so we can have this handy for later. Because there might be some other accounts that return some other... What is it? What is it called? That return some other results. Sure, let's call them results. Alright, so let's take a look and see if we can get some user shares. Some file shares. Okay, so we've got read access to all this other stuff over here. So netlogon, sysvol. I mean, most of the time, you don't find anything in shares like netlogon and sysvol or IPC, but we've got this non-standard share over here called users, and we can take a look inside there. So we can look at this manually using SMB client. just need to replace the IP address and the username, or the share. So the share is users, and the username that we're going to log in as is ybob317. Let me just copy that. Okay, they can ask for his password, paste it in. Okay, so all users, default user, ybob. What can we do with this? I don't know if we can move into these other directories. Let's try the public directory. Okay, so we can't look in the public directory. We can probably look in ybob's directory itself. Okay, we got... Oh, you know what? Maybe... I think there's something we can do with netexec to... All users hype? I'm sure there's nothing... All users hype? I'm sure there's nothing there. I'm sure there's nothing... Well, you know, we need to take a look around. I think there was... we can use the spider. The netexec spider module. So, let's see. So there's something in netexec. It's called the spider... Spidering shares. So using the module spider plus, using the default option spider. So spidering it out means it's like a tree dump. Using the default option spider, using the module spider plus. Well, I mean, spider plus has less stuff to look at, so I guess we'll use spider plus. Okay, so we'll try that. Dumping all files. Using the option O download flag equals true, all files will be copied onto the host. I mean, that sounds like a more efficient use of our time. They missed out on Spider-Man. If only they used Spider-Man. Okay, so let's see if this works. Because we want to get all the stuff at the same time. And we don't want to waste time. Sepson, I'm not too sure how to pronounce your name. Sepson, hello, nice to see you here. Okay, we got ads running on Twitch, we're running them on YouTube. And let's put on the baby birds. This is my favorite video, everybody. Enjoy the birds, we'll be back in about 60 seconds. Need to get myself some water. Smetric says that the ads are done, so I'll believe him. Let's see. Internet Doggo. Of course the Internet Doggo loves the birds. Okay, let's put the birds away. Let's get back to the hacking. Reconnection attempt. Are we having problems connecting to the server? That's no good. Wait, did we run out of time? Okay, so we need to make sure that that we keep track of the time. There's a time limit on these TryHackMe machines. Throttled? Maybe throttled. Yeah. So we might not be able to download as quickly as we want. Looks like the module slammed the server. That's very possible. Okay. Okay, so let's take a look at the password spray output. So we only want to see the positive lines. So we're going to grep out for the plus sign. Yeah, so there's only 3 accounts that that came back positive. So YBob and then a couple of guest accounts. But because they're guest accounts, they don't really mean too much to us. Alright, so I guess we should stop, because we're not getting any results like this. Okay. So did we actually download anything there? It doesn't look like we downloaded any. Actually, wait. It might be in this directory. NXC hosted, NXC Spider Plus, and then this IP address, and then sysvol, soup e decoded. Yeah, okay. Policies, I mean, this isn't exciting stuff. This is not exciting stuff at all. Man, why is this so difficult? Okay, well. Yeah, we should tree that. We should really tree that. But anyways, let's get out of here. I think we should you only got a directory structure. When you get the urge to navigate the registry. Okay, so what we were doing. SMB client. Okay, well, let's get in there again. YBob 317. Okay, so what are some other potentially juicy directories we could try? So admin. Okay, we can't look at the admin directory. Can we escape from our current directory? No, we can't escape from the current directory. How about all users? So there's admin, there's administrator. No access here. Okay, let's go into the all users directory. NT status stopped on symlink. So wait, what is this a symlink to? All users, default user. Default. What? I mean, there's just a ton of stuff in here. It's going to take a long time to parse this stuff. I mean, we could just go into, let's see, my documents or desktop documents. Okay. Let's move into desktop. Nothing here. How about my documents? Wait, did we already go in there? All users is program data. All users is program data? You can also use tree on SMB, can I? It tells you how often I use SMB, not very often. CD / stop spamming. Well, I mean, spamming is kind of what I do. All right, so we can use tree. I mean, I don't see tree. Help. NetHood might have some goodies. So what are we looking for here? Stored creds in a link. NetHood. I don't know the NetHood directory. So, are you talking about the default users? NetHood. NetHood. Okay, denied. So cookies, application data, app data, desktop. We looked in, so I should check out the desktop and the downloads directory because, you know, there's often stuff there in these CTF challenges. Desktop. And downloads. Nothing here. I always scrape bookmarks and favorites. Okay, that sounds like a pretty good idea. So favorites. Nothing here. Okay, so let's see if there's some other stuff. So default user. I mean, it's probably going to take me to the same place, right? Okay, but we can't look in default user. You'd be surprised how many companies store logins and URLs. That's kind of funny. Let's get this desktop INI just in case there's something juicy in there. Have you looked at ybob317? Yeah, I was gonna look in there last because it's the last on the list. So default user, public. Let's take a look at the public directory. Okay, can't look in public. So I guess the last stop is ybob. Okay, NT user INI. We got pictures, we got recent. I guess we can go through these one by one. So pictures, desktop.ini. Didn't we already download a desktop.ini? Yeah. Okay, so pictures, we looked in there. Recent. We can't look in our own directory. Save games. Another desktop INI. Searches. More desktop INI. Send to. Permission denied. You can dir directories without CDing into them. I mean, I'm just kind of like, you know, used to moving into directories before running, before listing them. SMB client kind of you can't run tree, but you can run C recurse ls. I mean, I think we're almost done. We're almost done here, so let's play some StarCraft. Okay, so start menu, send to, start to. Can't look at that. Templates. And videos. So it's pretty much a bust. The only thing I can hope is that there is something juicy in the stuff I already got. Because I guess we could also go into the default directory again and, you know, we'll take a little bit more of a look around. but I'm pretty sure... Oh, links. You know, I don't think I looked in links or local settings. Leo Pizzas, nice to see you here. We're just trying to hack this Windows machine. Not having... Well, I mean, we've had some luck. NT-user... What? NT-user DAT? Isn't this a super secure file? I kind of forget. I haven't hacked Windows in a long time. But let's download these files. And we'll get the log files as well. Which method of hacking? Well, I mean, we're mostly using, we're mostly looking inside of the SMB protocol. Okay, we got a bunch of files that we downloaded over here. Some of them might give us some answers. Not sure. Localized resource system root. This doesn't... I don't think that's anything relevant. ntuser.ini. Why is it spelled like that? That's nothing. Reverse shell? I mean, we don't have a reverse shell yet. Okay, ntuser.dat. Windows hacking, ntuser.dat. SMB, great. What kind of protocol is it? So user account forensics, ntuser.dat, rules. Rules? Rules, tools, structures, and dirty hives. Thank you very much, Chowzard. Chowzard? That's a great name. Thank you very much for following on Twitch, Chowzard. Let's give you a fun redeem. How about some... Ooh, how about some numbers?
Hey! Who are you people? What do you want from me?
You want the numbers, Mason. You want the numbers. That's all we've ever wanted.
Okay, so the posts...
Hey! Who are you people? What do you want from me?
You want the numbers, Mason. You want the numbers. That's all we've ever wanted.
Okay, the post focuses on ntuser.dat. However, the rules and tools can be used for other registry files such as system, SAM, security software, and default. Okay, so know the rules before using tools. We can be masters of tools, quickly refer to them, and start analyzing your files. Okay, so... The ntuser.dat is the primary file for the HKey current user hive and keeps user-related information. Windows is not updating this file in real time. Okay, so when the system is running, the data is being stored in transaction logs. ntuser.dat collected from a victim system may not contain the most updated data, as we are conducting the live analysis, and transaction logs data may not have been transferred into the primary file. Okay. So some tools make... Okay, I mean, what are the tools? No, thank you. Windows built-in command. I mean, we're not using Windows. Reg Ripper. So Reg Ripper, Registry Explorer. I wonder if we can just read the file, and maybe we can get some. We can grab some information from it for like maybe we can string some, get some strings. Let's just read the file. Okay, well, there seems to be a lot of let's see, binary data that we can't read. Let's try strings, running strings on it. Okay. How did you get the file from the target? So it was sitting around on one of the file shares. Okay, so we're looking around for anything that might be a potential username or a password. Don't think I see anything. Does SMB need the password to share? Yeah. Yeah, I mean, we've been using netexec over here, and I wonder if there's some other things we could be doing with netexec now that we've got a proper username. So we looked at the shares. I guess we could... Hold on. We're doing that over here, I think. Do not use the registry key. Of course not. Actually, wait. Do not use this registry key. What? I thought there was something in grep that you could use to get the lines before and after the grep item. Is it like C? Yeah, okay. So do not use this registry key, and then some stuff. Yeah, A5, B5. You can also use C for before and after. I mean, the other thing is we've got the logs as well, so we could take a look at the logs. Okay, I don't see anything super suspicious here yet. Let's try the other file. It's the same, looks like basically the same stuff. Okay, So let's see, what was the name of the user again? Was it ybob? ybob317. We can do all sorts of other enumeration with netexec. Actually, maybe we could use NetExec to do some LDAP stuff, because I really don't do... I haven't done very much with LDAP before. I need to teach myself. Okay, so... users... I wonder if this is going to give me... Oh, you know what? There might be passwords or other interesting information inside of the comments here. No way this is an easy box. Well, I mean, easy is relative. Easy is relative to other stuff. I mean, I haven't been doing anything super sophisticated. It's mostly just SMB stuff. So sometimes there's important information in the comments over here for the users. So we didn't see any other users when we went into the file shares. I'm keeping a lookout here to make sure that there are no credentials or anything else suspicious. Nothing so far. Okay, so what else could we be looking at? Okay, we'll take a look inside the NetExec wiki. We'll take a look at some stuff for LDAP, because there's LDAP available. So LDAP checker, I mean LDAP. FTP, different protocols here. LDAP protocol authentication. So authentication, testing of account exists without the Kerberos protocol. Testing credentials. So this is all kind of new to me. Let's try some LDAP. We can also look through these users over here to make sure that there's no weird stuff in the comments, because CTF challenges love hiding credentials in this stuff. Okay, that's not it. Great. Just a second. Where's my NetExec? Okay, so NetExec, we're going to be doing LDAP stuff now. LDAP. Yeah, okay, so we can authenticate as this user. Next thing we need to do is figure out what? Testing credentials. So we can enumerate domain users with LDAP. I've never done this before, but you know, it might as well try it out. And while this is running, yeah, okay, this is the same stuff. Actually, this was much faster. This went by much faster than using SMB. Ayanashi, hello, nice to see you here. It's been a while, but welcome back to the.
Hide the planet! Hide the planet! Shut up again!
Welcome back to the stream. Okay, so yeah, nothing super interesting here. All the same stuff. Hold on. You know what we could do? We could save this. So we could save this to let's just call this the userglob.txt. And then we can get rid of everything that includes, you know, some of these common descriptions. Oh, busy with work. No worries, no worries. If you're busy with work, you're busy. Better busy than bored. Userglob.txt. And then we will start grepping out these common descriptions here. So grep v for music. And then we'll grep v for classic. And then we'll grep v for art or science fiction, because this stuff keeps on coming up over and over again. Okay, and then we'll get rid of the sustainable living advocates. And we'll just keep on going until we eliminate all of these descriptions, and then we'll know that there's no more interesting descriptions to look at. Grep v home for home brewer, and then we'll get rid of the art enthusiasts and the volunteers. And then we'll get rid of the yoga practitioners or the cyclers. Okay, and what's next? So the tech geeks. I mean, there's not very much left, is there? There's still a lot left. There's still a lot left, huh? Let's see if we can make it to the top of the list. Okay, I guess we need to keep on going. Do you use Waka Time? Waka Time? I don't think so. Okay, we got a break that we need to take. Okay, so enjoy the birds and the music. We'll be back in about 60 seconds. Okay, let's put the squirrels and birds away, and we'll keep on use some regex to just get the descriptions and then unique them. Yeah, I mean, I think we could do that, but then again, we also need to keep the usernames here. We also need to keep the usernames here because we need to, if there's, you know, like some password or something, then again we can reverse it if we find something as well. So how would we do this? Internet Doggo, hello, nice to see you here. Okay, so the user glob is this. We just want to get the hold on. Let me make the output a little bit smaller. Okay, so this is the... I guess we'll separate it by this over here. So the colon. So this is where we learn how to do Linux foo stuff. So cat it out, and then we're going to cut D, cut by the colon, and we'll return the second field. Oh, that's unexpected. First field? The first field is this. What about the comments, though? What happened to the comments? Why does everything disappear? Why do the comments not? So we can do cut D by... I mean, we can't do cut D by the spaces, because that's going to be really inconvenient. So I mean, what happens if we do? So cut D by space, field 5, nothing, okay. Field 3, field 2, field 1. Field 1 only returns LDAP. How do we only return the comment portion? Okay, so Internet says it's possible that they want you to target a specific user based on their description. I mean, that's... I think that's possible, yeah. But how do we... I just want to find a way to isolate these descriptions, the comments. So if I cut by the colon, I get this. So this is the first field. The second field is absolutely nothing. Where are the comments then? The comments are completely eliminated. We could also cut by the dashes over here. So cut by oh wow, okay. You know what, that's funny, okay. So if we got all the descriptions here, then we can do what? We need to do some more refinement. So cut by, I don't know. So there's a space, 1, 2, 3 spaces. So cut by the spaces and return the fourth field. The fifth field, the third field, the first field, the 10th field. Okay, we shouldn't cut by spaces. That's what I've learned. How about we eliminate? We eliminate all of the spaces. So we do tr delete spaces. Okay. And then we will cut by the number 2. Actually, wait. We'll cut by the colon again. So cut colon. So first colon, second colon, third colon. So field 3. All right. So we're much closer now. And you know what? We don't even need to be so precise. We can just do, well, we probably want to get rid of these 3 numbers. So how do we do that transformation? Just a second, everybody. Just need to start up my music again. Okay, so Linux, remove first 3 characters in each line. So cut, what are they having us do? Delete the first 5 characters of any line in the text file in Linux with sed. Okay, so using cut C6. Cut C4. That doesn't look right. Okay, so cut C4 works. Man. All right, so from here, what are we gonna do? So from here, we unique, we sort, and then we unique. Huh. This looks suspicious. This looks suspicious over here. Yeah. So we see something weird looking over here, and let's go back. Let's go to another terminal. Let's go down to the bottom. Oh, you know what? I think it's part of this. Enumerated 455 local users. Okay, so just, just so we can make sure that that's what we looked at. So user glob, and then grep this out. Yeah, okay. So, I mean, we didn't find anything, but we didn't find anything, but I guess we did learn a thing or two about formatting our strings. Okay, so back to doing LDAP stuff. So to enumerate all users, to export all users to a file, to enumerate just the active users. So, oh, active users. This could have come in really handy. Okay, let's try this out. So okay, where's my LDAP? Okay, let's run active users to see who's actually active on the system. Is that everybody? Everybody's an active user. Everybody is an active user. Well, not that many users. So administrator guests. So I mean, this is more workable. This isn't 1,000 users, or is it? Let me check. Nope, this is still a lot of users. Never mind. Never mind. Okay. Okay, so next thing we can do is enumerate domain groups. I forgot to do as rep roasting. Yeah, okay. So as rep roasting, Kerber roasting, these are all common attacks, and yeah, I'm kind of sad that I forgot that I should be testing for this. So as rep roast, yeah, this is with LDAP. Great. This is a pretty common attack you do when you scan against Active Directory environments. Okay. So no entries found. No entries found, huh? Okay. Yeah. Okay, well, was worth a shot. Using a word list, you can find a word list of usernames here. Thornless Roses says SMB2 version 2 with signing enabled. I mean, that means that we're not going to be doing as many SMB attacks. Okay, let's try... So SMB, we can list the modules that are available for SMB. This will give us an idea of what we can attack. So we should probably be looking at low privilege modules. MS17010 or 010. That is what we call Eternal Blue. So we'll check for Eternal Blue. There's usually not Eternal Blue on these newer systems, but we need to check nonetheless. Okay. We could also try Zero Logon. So Zero Logon is a very serious vulnerability as well. If it's on the system, it actually automatically gives us root or like admin access. You can also try for Print Nightmare. Did you try RDP with creds? You know, we should probably try that to see if YBob can actually get in via RDP. The other thing we could do is we could enumerate our own users' groups and stuff, because they would usually be part of like remote users or something if they had RDP enabled. Okay, so Spooler, WebDAV, Zero Logon, Print Nightmare, we can check for this. I don't think we're getting anything on the Zero Logon. We'll check Print Nightmare. Okay, so Print Nightmare, it's not there. I think, let's see. We'll make another thing, another terminal. We'll call this one Remote Access. We'll make it a great color. Let's do green. And we'll do X-Free RDP3. We'll try logging on as HBob what? What was it? YBob? YBob. What was that thing again? YBob1317. With password YBob317. And we need to get the IP address. Okay, let's see if this person has the ability to log on. Nope. Okay, connection failed. I guess, oh, Kerberos, okay. I guess not. There's all sorts of Kerberos stuff that we haven't done either. But let's go back to the drawing board. So query LDAP. Okay, so let's see. As rep roasting, enumerate domain groups. How do we enumerate our own users' information? Get user descriptions. Maybe we can do that. So description, get description users. Oh, this is the wrong. We're going to do LDAP for this. Wrench! Hello, nice to see you here. Welcome in, welcome in. We're just doing a little Friday hack. Okay, so these are the descriptions. I mean, the descriptions don't really help us because we've been looking at these. We were looking at these before. Okay, password policy, min length. 3 options are available. What else can we do? Admin count. Kerberoasting. Kerberoasting is done with Kerberos, though. Oh no, Kerberos is LDAP. Right. Kerberoasting via as rep roasting, but we don't have... To do Kerberoasting, we need access to a service account, right? What do we need? We need a... Let's see. You don't have that domain controller IP, right? So, I mean, we do have the domain controller IP because there's only one machine on the domain. So this machine that we're scanning right now is the domain controller. Get user descriptions, unconstrained delegation. Trusted for delegation. I mean, might as well. Okay, so trusted for delegation. What are we looking for again? I mean, it looks like DC01. This is the domain controller machine. This is the computer. Enumerate domain users. I guess, I mean, everybody was a domain user, basically. To enumerate just the active users, yeah. I mean, we were just looking at this. Domain groups. Groups, domain admins. How do we get the LDAP information for our own user only? User descriptions. Bloodhound and Jester. Oh, you know what we should be doing? We should also be... I don't know if there's actually any real use to this, but we could also be running some responder, some Python responder in the background. So let's call this responder. Okay, we'll give this, I don't know, it's purple. And responder must be run as root. Do we need to specify an interface? Yeah, we do need to specify an interface. Okay, so we'll just run responder. We'll see if there's anything funny coming our way. We'll just leave this running in the background. So dc01.soup edcode.local. Okay, so how much time do we have? Well, if we got 40 minutes left, I think I might get a hint, and by get a hint, I'm going to read the description of the room, because it tells you. Apparently, it was telling you what kind of stuff that you need to do in this room. Kerberos authentication, navigating SMB shares, password spraying, pass the hash techniques. So Kerberos authentication. So the SMB shares, there might be something in the SMB shares that I still haven't found. Okay. So we should probably look through the SMB shares. And another thing we need to do is we need to add some time to our machine. Okay, so SMB client is not very fun. Let's see. So SMB file shares. You know, I'm kind of sad that the spider module didn't work, because I really would have appreciated dumping everything onto my local machine. You know, let's try it one more time. Because we've got access. Oh, the backup. You know what? This is probably privilege escalation right here. Can you mget once connected? That's a good question. So my guess is that the backup share here is what we need to get access to, and then that's going to let us do some privilege escalation after we get access to it. So sysvol net logon IPC. What were we doing? We're doing SMB client. ybob 317. It's 10.201.84.48. Let's try looking in the... let's try IPC. I've never found anything useful in IPC, but there's the first time for everything. Wait, let me try connecting again. Oh, I misspelled IPC. SMB get -R. Okay, let's take a look at what's in here. There's nothing in here. Okay, well, let's get out then. So IPC was a bust. Net logon, we'll try that one next. Actually, wait. Let's, just in case this is interpreted as, you know, something weird. Yeah, there's nothing here. Okay, so the next one we're looking at is net logon. Do I have to do that all caps? I do. I need to do it all caps. Okay, there's nothing in here. I guess we will exit then. Can we move into another directory? No, we can't. Okay, let's get out of here. The other directory is sysvol. Okay, there's something here. I don't know what this directory could be, but we'll go in and see what's up. Nothing. Nothing. Okay, we got scripts, we got policies. You haven't been checking for hidden files and directories. We do dir/a. dir/a. I don't think you can do dir/a in SMB. But Thornless Rose, you're right. You're right. I think sometimes you can look at hidden files, but you have to be already on the system. Okay, so scripts. Yeah. So scripts, policies. I guess we can try entering these directories. Machine and user. Microsoft, I think we've seen this one before. Yeah, Windows NT. Okay, I don't think what we're looking for is here. We'll take a closer look at the users directory that we found last time, or the users share. Oh, you know what? Okay, I forgot what. Yeah, MC25 said something about SMB get R. Well, I'll check to see if I can do that after I log in via SMB client. Okay, so back into the users. Sure. Oh. Why am I? Okay, I'm in. So help. So what was the command that MC25 was talking about? SMB get. I mean, I don't see it in the list. Can you mget once connected? Mget, I don't see mget. Oh, mget is here, yeah. So, I mean, can you mget everything? Nothing to mget. I'm not too sure how to use mget. Just a second. I need to take a little water break. How about mget star? Okay, so mget star. Do we need to say yes to all of these? It just gets one thing? Might need prompt off. ECT. ECT? Oh. Can you do it recursive? Prompt off? I mean, how do you switch prompt off? Is it mget star prompt off, recurse on, prompt off, mget star. I mean, yeah. This is looking good. Yeah, thank you very much, MC25. This is much better than looking through manually. Although I guess we're going to be looking through manually afterwards, but it's going to be much faster if we're doing it on our local system. Edwin, hey, what is up? We're just doing some Windows hacking over here. Yeah, I mean that's a good trick, MC25. Thank you. I very much appreciate that. Okay. So I guess we can look out for some juicy looking files over here. Same for FTP. I mean, oh, okay. I mean, the thing is that, yeah. I mean, there's no FTP on this box, but it's a good trick. So it's prompt off, recurse on. But this is very handy, yeah. Okay, well, I mean, this is going. I guess we could... What else could we be doing in the background? So there's LDAP, there's... It mentions something about Kerberos here in the description as well. I'm guessing that we get access to a Kerberostable account, and Kerberosting is usually done. Oh man, I need to refresh my memory on what Kerberosting is. Kerberosting. What is a Kerberosting attack? Okay, let's refresh our memory. So it's a post-hacking attack targeting the Kerberos authentication protocol, enabling adversaries to extract encrypted service account details, credentials from Active Directory. Okay, so an authenticated domain user requests a Kerberos ticket for a SPN, Service Principal Name. So we need to get... Oh, right. So we need access to an SPN account. So after we get an SPN account, we can do the Kerberosing attack. Yeah, okay. Alright, so I think we're done with our mass downloading. Just get out of here. So we'll go into... So we have all the directories here. So let's go into Administrator. I'm kind of surprised. There's nothing here. Okay, well that's great. What other directories do we have? So we got all users. Oh, we can do tree. What do we got? We have a lot of Python scripts, apparently. Let's go to the top of the tree. Man, there's just too much stuff. Alright, let's start at the top. Desktop links. Truffle Hog, please. What is Truffle Hog? There are all sorts of tools that I don't know about. If Truffle Hog is some sort of tool that you can use to, parse through files, let me know. We could also just run grep. We can grep for password, or we could grep for some other, weird keywords. So these are all links. TruffleHog is a file scanner for detecting API keys and other juicy stuff. Huh. Oh, it's in the Kali repository. So Thornless Rose, if you let me know what the syntax is for TruffleHog, I would appreciate it, because otherwise I don't know how to run this thing. TLDR. TLDR is not installed. I mean, I like TLDR. So looking at the man page for tree-a is for all files. I mean, did I not do all files? Hold on. Tree-a. Okay, so, I mean, same stuff. TLDR TruffleHog. Okay, so TLDR update to download the cache. I guess we need to do that. And then TLDR TruffleHog. Scan a Git repository for verified secrets. Scan a Git organization. Scan an S3 bucket. Scan individual files or directories. Okay, so I guess it would be TruffleHog, file system, and then current directory. Okay, so TruffleHog file system /. What? Let's check to see if there's anything extra fun in here. Well, I mean, I don't... TruffleHog file system dot. Still doing SMB client. I mean, we finished with SMB client. Hold on, let me put on some more music. Okay, I don't think we're returning anything with TruffleHog, but we can just do some manual enumeration. So we got a bunch of Python files. Oh, you know what? This is... No. These are the Python... These are my own Python files, because we're doing the entire temp directory. So we can ignore this stuff. Yeah. So we can ignore all this stuff, move on down. Okay, so let's see. Password spray, error opening directory? Sure. Thornless Rose, I think you're trying to imply that I missed something. If you think I missed something, let me know what you think I missed. Okay, SSH. What is this? Error opening directory. Oh, that's my Kali stuff. Desktop INI. Yeah, the logs, right? Okay, groups, content, desktop INI, more stuff. Console history. This could be really good. So consolehistory.txt. It's funny that you scanned your whole Python install. It's because I created a Python virtual environment earlier. So I think this might be it. It's Windows. Let me record the path. So it's PS readline. Console history, Windows, Microsoft roaming, okay, Microsoft roaming, app data, app data ybob 17. ybob 317. Yeah, so it's just ybob 317, I'm pretty sure. Actually, you know what? I can just find this. Find current directory name console host history .txt. Here we go. Let's read this thing. What? Is this absolutely nothing? Is this a password? This might be a password, I don't know. But there's nothing here. That's really funny. Okay. Thank you very much for following, ASX. Thank you. Thank you, thank you. Much appreciated. Let's do a netexec SMB password spray. So, user mod, I think? And the password spray is going to be this. Of course, we need to put some quotes around this. And I guess we'll output that to something else. Pass spray 2.txt. And we'll just make it one word. Okay, run that. And is it done? Oh no, we need to add something else. We need to add no brute force, and we need to do continue on success. Okay. That's how you do password spraying. So we'll just leave this alone for a second, and we'll come back to it later. So I'm kind of disappointed that, well, I mean, if this isn't actually a password, then it's very disappointing. Otherwise, let's take a look at the tree again. So let's see, nt-user ini. We got user.txt. Yeah, so we can submit our user flag. Okay, let's submit the user flag. All right, so find Bucket XP. That's a great name. Thank you very much for Thank you very much for following on Twitch. Thank you. Okay, let's cat this thing out. Here's our user flag. Let's submit the thing. Where are we? Here. User flag. Done. Ooh. It it plays a sound now when you submit your flags. That's nice. Okay. So this is still going. So I guess we'll leave it alone. Okay, what other files? I guess everything we're looking for is going to be in that user's directory. So desktop.ini. I thought I checked the desktop directory, but I guess I didn't check it. It's a little disappointing. A lot of link files, console host history.txt. I mean, I'm guessing that we found a password in the console host history. Okay, this is also users.txt. Oh no. This is our own. Yeah, this is our own thing. Thank you very much for following Thornless Roses. Thank you very much. Much appreciated. Did you check Who Am I Priv? I mean, I haven't been... I guess I could. You're right. So check privileges. Check user privileges. Or I guess we can just search for privileges. Priv. Putty. So if you know the command inside of netexec, then I would appreciate it. But I'm pretty sure it is LDAP, right? Okay, so let's check to see it's still going. Okay, let's take a look at password spray 2. Pass spray. Okay, so we're gonna be getting rid of failure here. Grep v fail. It looks like we haven't found anything. I guess we need to wait until it completely comes back first. Oh, it's done. Okay. This is all logon failure. We could also just grep 4, the plus symbol, which means we logged on successfully. Okay. Yeah, netexec it's a pretty good tool. I really appreciate it. So is it just this? Is the password actually that? And this is just some extra stuff? We could also try this. What about psexec? I mean, psexec, we need higher level access to use psexec. I'm pretty sure the user that we have right now, they're not able to run it. That could be a command on the system that he ran. I mean, he ran who am I, and he ran... I mean, what could that command be? Or is it... here? This. Jock. Or whatever. We'll run the password spray one more time. So user, okay, we need to do it with continue on success and no brute force. Password spray or p spray p spray 2.txt. Do a tree and a grep for jock. Yeah, I mean we could grep for that specific term. Cypher Enigma, hello, nice to see you here. Have you run Bloodhound as the 2 users that you have? I don't think I have. No, I mean I definitely have not. But Bloodhound is usually something I try after I get initial access. Okay, so we can try grepping for that weird string that we found, this one right here. Okay, so we grep recursive in the current directory for this thing. I guess it's gonna come up as a failure because we recorded this thing. Okay, what else do we have? So we got permission denied, yeah, the password spray, the console history, that's where we found it initially. You have creds, you can do remote collection. Okay, well... let's see, what's the best way to do... Oh, another thing we can do is we can see if anything came back in the responder. Nothing's come back on the responder, that's fine. Bloodhound is probably the first thing I do when I get creds. I haven't done a lot of stuff with Bloodhound, so I should probably teach myself how to use Bloodhound better. I think... there's like a Python thing you can do with Bloodhound, right? Actually, wait, you can do Bloodhound with netexec. Yeah, that makes a lot of sense. We should use, let's see, Bloodhound. Maybe I can just search for it. netexec LDAP Bloodhound collection. Oh, okay. Cypher Enigma, thank you. Thank you for the syntax. Okay, where are we? We're here. Okay, so user pass IP 10 to user, what was it? ybob 317? Was it 317 or something else? Yeah, 317. Password is the same thing. DNS server is going to be the same IP address. Okay, let's give it a go. And I just need to double check to see that I'm not running out of time on the machine. We got 1 hour and 6 minutes. Okay. Oh, why didn't it work? Did I give the wrong command? Everything looks okay. Yeah, I wonder why... I wonder why the command didn't go through. Okay, so I'll try giving the error message to the AI. Maybe it can help us out. Okay, what's going wrong with netexec? DNS resolution failure and a login related attribute error. So the primary issue is that netexec is failing to resolve DNS query while running the Bloodhound module. Okay, so this timed out. The DNS server is unreachable, the target domain does not exist or is misconfigured. A version mismatch between Python's logging module and netexec's custom logger. So check the DNS connectivity, adjust DNS timeout, fixing the logging error, updating netexec. Ensure that you're using the latest version. Alright. I sure hate messing around with netexec because it might break it. It doesn't want to update the thing. Yeah, I mean, netexec is kind of fragile. I mean, it's I just need to make sure that this is the correct IP address. Okay, I mean, I can contact the dang thing. Let's try it again. pipx upgrade netexec. Oh, I'll give that a try. If this doesn't go through, I'll give it a try. Yeah, are you gonna work? Nope. pipx. Aren't you in a shell yet? No, we haven't managed to get a shell yet. Package is not installed. Virtual environment? Oh man. Do we need to go into a virtual environment? I mean, I guess I could. I guess I could. It couldn't hurt, I suppose. Why not run Python tools in their env? Their env. Alright, let's do the virtual environment again. Python m venv my env. Virtual env my env. Okay. Source my env bin activate. Okay, so we're now in here, so we can just thank you. Hack Smarter has just rated with a party of 44. Thank you very much. Thank you for following. Yuply, that's a great name. Let's give everybody a fun video redeem. How about some war games? We got people following.
We're in.
Shall we play a game?
How about global thermonuclear war?
Thank you very much, Forsaken. What is that number? I don't know what Roman numeral that is. IX, that's 9? 9, is it 9 or something else? But Forsaken, thank you very much for following, and you know what? Welcome in, Raiders. My name is the Shy Hat, and if anybody's here who doesn't follow Hack Smarter is another great cybersecurity content creator, and you can find them at this channel right here. It's just 10. Okay. Yeply says, thinking of making the switch from Windows to MacBook Pro with an M4 chip. Good idea or no? I mean, I've never used Mac products before. Well, I mean, I used an iPhone for about a year, but that was about a decade ago. So if anybody in the chat has an opinion on whether or not to switch from Windows to MacBook Pro, please let Yuply know. Thank you. Okay, so can I use my netexec inside of the virtual environment? Okay, well, I mean, some people are very vocal about. Okay, so let's see. Pipx upgrade netexec. Package is not installed. How about pip install upgrade netexec? Could not find a version that satisfies the requirement. Netexec from versions none. Can we just do pip install netexec? I mean, that might break my netexec. Yeah, I mean, anyways. What else are we doing over here? So everybody, thank you, and welcome in, Raiders. My name is the Shy Hat. I do cybersecurity education here on Twitch and on YouTube, and right now we're hacking against this module over here. It's called Soup Code 01 on TryHackMe. Let's see. Thornless Rosa says netexec is barely compatible with itself. Installing it in the root Python environment is likely to break everything. Pebble says, got a MacBook Pro with 64 gigabytes RAM. It's snappy, it runs very well, but it's a pain in the butt getting used to Macworld from Windows and Linux, keybinds, and desktop navigation. I mean, oh, okay. Pebble says, oh, you didn't buy it. And you know, Pebble, you just recently got a pentester job. Let us know what kind of stuff you've been up to at your job, because, you know, we're all very excited to hear about what kind of stuff you've been learning. A lot of people in the chat also want to become pen testers, so I'm sure they have a lot of questions that they want to ask as well. But if you want to lay low and not answer everybody's questions, that's fine. That's perfectly fine too. Okay, so So P-Spray, don't think we managed to get any passwords here. Nope, didn't manage to find any passwords. But, you know, Pebble, I'm surprised. I'm surprised that they gave you a MacBook for work, as opposed to giving you some sort of Windows machine. But then again, every work environment is different. I wonder what the reasoning is behind giving everybody a MacBook. Okay, so I'm kind of running out of stuff to do. We did read over here that we're supposed to do some compromise using Kerberos authentication. Kerberos authentication. Navigating through SMB shares. I mean, we looked through the SMB shares, but we weren't able to find anything. We found the user flag. We didn't find anything else. We did our password spraying. We didn't use the pass the hash technique. How do we... Oh, okay. The Ken PDX says the job... Ken PDX's job uses MacBooks. It's just the culture. Okay. For all the assessments, use to SSH to a Linux attack box. SSH to a Linux attack box? So you got like your double remoting. So you SSH to the Linux attack box, and then from the Linux attack box you do the actual attacks. That's interesting. The hardware is just incredibly good and easy to transport. Well, I mean, that's great. Let's see. You said you weren't familiar with Kerberos. I mean, it's been a while since I've done a lot of Windows hacking. So Kerberos, I mean, what can we do? Okay, so using Kerberos authentication with netexec -K. I mean, if we do LDAP, using credentials, using certificates, using modules, DNS options, there has to be something fundamental that I'm missing here. SMB, okay, Kerberos. Pebble says, in regard to my start at work, it's been mostly onboarding stuff this week. I'm shadowing an external assessment and starting my own the following week. Wow, they're really throwing you in pretty soon, huh? Let's see, toss a K into the Bloodhound you were trying. The Bloodhound that I was trying. Are you talking about Bloodhound? Where was it? So we're doing Bloodhound like this, and then add in a K. HackSmarter says, that's awesome. Externals are super easy. It's basically Nessuscan and finding low-hanging bugs and try to hack the web servers. Yeah, I mean, externals, they don't usually expect you to break in most of the time because it's usually secured pretty well from the outside. Except for the public-facing stuff. The public-facing stuff, yeah, it's going to be web servers. Can you read scheduled tasks? If I recall correctly, some scheduled tasks created with backwards compatibility enabled saving raw authentication hashes within them. Scheduled tasks. So, I mean, how would you search for scheduled tasks specifically? Okay, so... This time it had an error connecting. So we got our Bloodhound, we got our collection technique. I guess we could also turn off the DNS server. Just like what the handy dandy AI was talking about. What was it here? So the DNS timeout is the main problem. Fix that first. The logging error is a secondary bug. We could try running it... What was it? With no DNS. I mean, if it's not hallucinating, then sure. Adjust DNS timeout. Okay, so no DNS. A little while earlier, you accessed the domain controller's policy files. Okay, so no DNS is not a real. It's not a real thing. What else can we do? DNS timeout. DNS server. We could adjust the DNS timeout as well. And I'm not too sure what it's using for DNS timeout. So I mean, is it 5? Is it supposed to be 500? I think it was in a share. You access the domain controller's policy files, and you're talking about scheduled tasks. I mean, what? Is it working now? I think it's, yeah, it's still giving us our error message over here. Lancelot 007 says, what are you trying to do? So we're trying to hack a Windows Active Directory domain controller, and the challenge is located over here if you want to give it a try yourself. Rusthound never fails until it does. Rusthound, huh? Okay. Well, I mean, we could not use netexec. So we're trying to do a remote Bloodhound collection right now. So what was it? Bloodhound? Is it called bloodhound.py? Okay, let me just search for remote Bloodhound ingestion or collection. Okay, bloodhound.py remote ingestion. So we'll take a look at this article. If anybody has handy dandy command syntax, I would really appreciate that as well. Lancelot 007, thank you very much for the follow. Much appreciated. Okay, so we got some bloodhound.py not found. Locate bloodhound.py. Bloodhound.py is here. So Python bloodhound this. Okay, test.local. I mean, soup e decode.local. I guess we should also save that thing to our etc hosts file. So dc test.local, and we got our NS. I'm assuming that's the IP address. Just a second. So we got our IP address here. And let's see, dc dot edcode.local. Let's see if this works. Could not find main module. Oh, you know what? We're in the virtual environment for Python. Deactivate. Huh, couldn't find this thing. Alright, well I mean maybe we don't have it installed. Or maybe the installation's not good. Okay. Based on impacket, maybe we can download it. Bloodhound Python, Bloodhound .py, GitHub. Okay, so Bloodhound.py is here. We can just git clone the repository, and hopefully we can get going after that. Git clone this thing. What Python version does it expect? I'm not sure what version of Python it expects, but it says that it can't find the main module. I'm assuming it's going to be Python 3. Message got hit with the motto odd. Green on white. Okay, MC25, you can get it. You got it over here. Green on white? Green on white. Where is it? I don't know where you might have seen that. Oh, the text on the page. This page? Oh, yeah, this page. This page. This is, yeah, it's not very easy on the eyes. Okay, what are we doing? We need to move into the directory now. So, Bloodhound Pie? Bloodhound Pie sounds like an English dessert. Okay, so we're gonna run the local. This directory is Bloodhound Pie. Do Python 3 instead of just Python. I mean, Python is a symlink to Python 3, so it shouldn't make that much of a difference. So Python on Kali Linux is Python 3. Okay, looks like it's given us error messages. So D is domain, U is username. Oh, we need usernames and passwords. Okay, so let's try including the usernames and passwords. Username ybob317. Password is also ybob317. The D, -D and DC spelling is off. Soup, oh yeah, you're right. So it's soup edcode.local. And this one is soup edcode.local. I need to double check this. Soup edcode.local. I mean, we might as well copy and paste this, because otherwise, you know, just so we prevent ourselves from making any spelling mistakes. Okay. And this one. Okay, it is... What is this? The resolution lifetime expired after so many seconds. The DNS operation timed out. So it looks like there's some problem with the DNS. I'm not exactly sure how we resolve this. I mean, we know that the DNS is here, so I guess we need to do some... We probably need... Okay, so dc01.soupedcode.local. Let's add this to our DNS. So, sorry, add this to our host file. So, let's see. Okay. And we need to get that IP address. Can add an hour to this. Okay. And let's try it again. Using domain hint something something. This isn't working. I get the feeling there's something I'm doing wrong here. So the domain controller, I mean D for is for domain controller, right? Let's just run this by itself, see. Maybe I can specify an IP address instead. DNS timeout. DC is domain controller. Maybe use TCP instead of DNS, or TCP instead of UDP for DNS queries. Because I think... But actually name server should be... Name server should be the DNS. Still giving us errors. Alternate name server to use for queries. Username, password. D for domain. Domain to query. Okay. Maybe for the DC we'll put in the IP address. I don't know if that'll fix... I don't know if that'll be easy or not. Or if it'll change anything. Okay, so not having a great time. Rusthound never fails me until it does, says Pebble. So maybe we'll check out Rusthound. We can just, we can use all the hounds. We probably need to download it from a GitHub repository. Okay, so Rusthound, Active Directory Data Ingester. So if all of these tools have DNS problems, then it has to be like something. It can't be the tools that are all malfunctioning. I tried to run a local DNS server, then point Bloodhound to it. It's just DNS after all. Well, I mean, let's Rusthound git k, get out of here, git clone the repository, move into the directory. How do we run this tool? It's probably just asking for the IP address of the DC. Okay, we need to compile it? Oh geez. Limitations, description, how to compile it. You can use the make command to install Rusthound, or compile it for Linux or Windows. Make install. I hope nothing weird happens when we try to create this thing. Let's see. Cargo is not available. Please install it. Rusthound, better and faster. Cargo is not available. Big if true. Well, they want us to do this. Proceed with standard installation. That feeling when you just want your tools to work. Okay, so Rust wasn't installed? Oh, I mean, I guess it wouldn't be. All right. Make install. What? Bloodhound is so hard to get working. I mean, sometimes yeah, sometimes yeah. Rusthound. We did not install Rusthound. Rusthound you can run in both Windows and Linux. I mean, that's good. I wonder if... Yeah, Rusthound is not part of the Linux, the Kali Linux repository. Otherwise, you would have the option to install it using this. Restart your shell to reload the environment variables. Okay. I mean, I can just open up a new shell. Make... what was it? Make install. Is it working? Is it working? Okay, so let's take a look at what the syntax is like. Simple usage. Thank you. Thank you for the simple usage. Resthound D. So specific Linux with username password. Linux tips to redirect and append to both standard output. So Pebble, if you have like a command that you like to use with RustScan for remote collection. Let's see, Bloodhound docs. Demo simple usage. Simple usage. Linux with username, password, and LDAP IP. Okay. Let's copy this thing. What are these? What are these examples? Wow, we're still installing the thing. Okay, so I guess while we're waiting it to install, we can start messing around with this. So this is DC01 dot soup edcode dot local. The IP address is this one. And the username is actually at soup e decode dot local. I guess it would be ybob 317, and we got a password, which is ybob 317. You can use Python, Bloodhound Python 2, since you are in the Linux terminal. I mean, we tried using Bloodhound Python, but we weren't having any success. So what is temp demo? What is the output? I mean, we can just put it in the temp directory. Okay, let's check to see if if it's finished installing. Did it finish? Where were we installing it? Oh, here. Okay. Are we stuck? Did we run out of did we run out of hard drive space? We've got one more thing to go. Okay. Man, I think we might need to call it here, because it is getting kind of late where I am, and I need to get dinner and all that other good stuff. But I'll keep on. Oh, it finished. Okay, let's see if we can run the thing. I do want to see if I can get the Bloodhound stuff. Okay, command Rusthound, command not found. I mean, I guess maybe we could do it from another terminal. What's the guy got to do to get some working Bloodhound over here? You know, that's a good question. Rusthound installed. Okay. Error, no data collected. Reason LDAP operation result, no such object. DC soup e decode, DC local. Did I spell that correctly? I might not have spelled it correctly. This is it. I have my notes on how to install Bloodhound. The moment when you decide to call it quits in your tools and you decide to start working. Yeah, that's happens all the time. Okay. Let's put in... So it's DC01. LDAP operation no such object. So connected to Active Directory. What do you mean no such object? Do I have something distinctly wrong? D might be the domain. Okay, so D is the domain, which means we don't put in this. It's working! It's working! Ah! Hype! Boundless hype, yeah, okay. Unfortunately, I gotta go. Let's talk about what we're doing next week. So everybody, you can help out. Because we're currently writing our schedule for next week. So we write out a schedule every week for the Hacker Frogs live streams. You know, I've got a highlight for Wednesday next week. So on Wednesday next week, we're going to be talking... Actually, let's see if we can make this dark mode, because this light mode is might bother some people. Okay, dark mode. There you go. Dark mode. So yeah, we've got the second place winner of the DEF CON social engineering contest. They're going to be coming on next week on Wednesday, and they're going to be talking about what it was like to participate in the social engineering contest at DEF CON. They're going to be talking about social engineering in general, about how to get into the scene if you want to become a social engineer, and we're going to be doing a bunch of other stuff. So let's talk about it now. So on Monday, we're going to be doing The Witness. It's another fun puzzle game. We're going to be playing that. We're going to be continuing on with our Nebula series. Maybe we should do some other stuff instead. So you need to continue this on next streams and the next stream. Well, I mean, I don't know if we can. Maybe we should. So we'll put in this one over here, soup decode, and we'll do this on Monday. So soup decode, this is going to be TryHackMe. and this is Windows. We'll do this tomorrow. We'll do an hour to see if we can get anything done there. Okay, we're going to be doing some THM volatility. TryHackMe. Oh no. Okay. We finished with this. The volatility essentials for digital forensics. We finished this. So what should we do instead? Some more Linux stuff. So Linux stuff, we could do. We've already done all of Bandit, and we've done all of some other stuff. I don't know what we could do for Linux. How about we do some Linux, huh? We could try doing a Volnix machine. Volnix.com. Or is it Volnix.org? So Volnix is another one of these platforms where we can do this stuff. Volnix.com. We download machines and then we can do some hacking against them. We might get an easy machine from Volnix. Where are they? Filter by easy machines. We'll try one of the newer ones. We'll try, how about Overseer? Observer? That sounds like a fun machine. So we'll try this one. So Volnix Observer. Where are we? So Volnix Observer, this is Linux. And I guess we'll also do a Docker Labs one if we have time. So Docker Labs, we're running out of easy machines on Docker Labs, and we need to do some medium level ones instead. So Docker Labs is another one of these really fun platforms where you can do hacking against vulnerable Docker containers. How about Bypass Me? Bicho? Have I done this one? I need to check. I do write-ups for all the rooms that I complete. Need to keep track of these things. The name is pretty fun. Okay, I don't think I've done this one, so we'll do Bicho. Okay, so let's see. So topic 4, we'll do Bicho on Docker Labs. Okay, so on Wednesday, we've got Hack the Web. We always do that. That's really fun. We can do more JWT attacks because we didn't finish all the JWT attack labs over at Portswigger last time, and we'll keep on doing our writing a web app. We're going to make sure that our PHP forum works, and I forget. So this is PHP BB that we're using. Okay. What else? So let's see. The social engineering talk we're doing that on Wednesday. And on Friday, let's see, we'll do human resource machine again, because, all sorts of fun assembly language stuff. The Temperance CTF labs, we completed 2 levels today, so we'll be doing, let's see, 28. And we're going to continue on with our Nightmare Reverse Engineering course. And as far as the free hacking portion, I'm not too sure. Maybe we might be doing SUPD code again. I'll put a question mark on that. So reverse engineering course part 2, and that's going to be the schedule for next week. So let's post this, and then so anybody who's not part of the Discord community. So we have a Discord as well, and if you want to join, you can use the link over there to join over on Discord. Let's see who is streaming right now. There are not usually too many people on Friday, but we'll see who's on for InfoSec streams. Okay, so it is Malware Tech Blog. Wow! Malware Tech is on. Hold on, let's see what they're doing. So if you don't know Malware Tech is the person who stopped WannaCry. And I guess he is streaming and talking about his DEF CON experience. Why do I get ads? Okay, let's take a look at what Malware Tech is up to. Might as well raid into well, I mean, Malware Tech is kind of a celebrity, and streaming to 59 people. Okay, so let's get that raid set up. Thank you very much, Thornless Roses. I appreciate the compliments. So raid malware. How do you spell that? Malware Tech blog. Okay, so when you arrive at Malware Tech Blog's live stream, if you could give this message, OS Frog, hip hop, hack, OS Frog, I would really appreciate it. Because, you know, we can show our solidarity in streaming. So there's that's not Malware Tech. Okay, everybody, we'll be back on Monday. Everybody, thank you very much for coming today. We'll be back on Monday. Hope to see you there. We're rating in 3, 2, 1, go.